Check my continue recording. No, pause recording. Hey, this is Coffee Compiler Club. Anything to do with compilers and language runtimes and garbage collection and nil or not the nil. All fair game. You're being recorded live. You'll show up on YouTube a couple hours from now. And that's sort of the it for my spiel. Look at my backdrop. See the big bookshelf is gone. And the pod shows tomorrow, and we load in. And a week after that, week and a half, we close. Knock on particle board. And the following coffee club may or may not happen according to how well moved in we are. So I might skip one while we get it sorted out. Okay. That was my spiel. I can do a tiny AA update. I'm in between moving. I'm hacking the main code to bring my theory approved version of typing system over. That's mid progress and going okay, given the amount of time I've spent on it, which is say not a whole lot. Day and a half out of the last week, maybe. Somebody on the YouTube lands asked about V8 internal IR. I don't know if anyone has a clue.
They've had some great presentations on the topic, and they keep changing it over the years. They've changed it like 5-6 times now.
It's a good sign up to a point, yeah.
Yeah, no, it's a lot of R&D. I used to have some links I had saved, but I don't think I have many more.
Yeah, but that's already enough to know to Google it. I'll tell my YouTuber to go Google.
And what's really cool is the first one I saw was actually a couple years out of date at the time. And I was like, oh, this is really brilliant. And then it's like, there was a link on it to a second one. And I watched that. They're like, yeah, we used to do it this way. And it was the stupidest thing ever.
Yeah. Yep.
And it's like, wait, I thought that was brilliant.
Yep. Until you sit down and use it, you never know. A lot of go-arounds on the sea of nodes that I cleaned up. So there's a lot of stuff that there's a theory that people have to wrap their heads around, and then there's a lot of details that make it pleasant to use and debug and whatever. And no one ever asked about that stuff because it's just like engineering things. But it's just as important as everything else. The right way to debug shit and the right way to handle all corner cases. How do you handle exceptions? How do you handle memory? How do you handle this, that, the other thing? You don't get it nice in any IR. It sucks either way. So there you go. Vaguely back in the day, we were looking at somebody else's Java IR when C2 was well along, but not yet the default. And how I handled exceptions, especially null pointer checks, was just so much better than what they were doing. And it just, once you stared at it for a little while and figured it out, it was like, oh my God. I put them in the IR like normal IR. All the null pointer checks on the planet are just normal IR if null. And then the normal optimizer cleans them out the normal way. And their code was full of a bajillion. If this is a null check, then do a following exceptional thing to see if we can do something about it or not. And it was just littered everywhere. And if you just made them normal IR, you made a lot of them. Most of them cleaned out right away. But then the optimizer does what the optimizer does, which it's really good at cleaning out null checks. And they all just disappeared. You didn't have to have any special cases for them.
Yeah, I pasted in one of the old ones I watched. But there's a bunch. And they're very interesting.
Yeah, okay.
I've lost a couple days actually watching them and then like going through the code and trying to understand what they were talking about.
Sure.
But it's beautiful code actually.
Okay.
Because it's so ugly. They put a tremendous amount of effort. If I remember correctly, I want to say it was C, but if it wasn't C, it was C++ written like C.
Yeah, that's what hotspot is. C++.
And you're talking like, like tens of thousands of lines of kind of setup code, all macros, like basically a big Excel spreadsheet built with macros of, this op, and it like auto numbers because it's as the compiler is running, it's got state and but
Is this for the IR description pieces, or when you're parsing a piece of JavaScript and emitting IR?
No, this is all on the interpreter and JIT side.
Yeah, okay.
That I'm talking about.
Yeah.
Yeah.
The hotspot interpreter is all macros, kind of.
Right. And you might actually recognize the name of some of the authors that worked on V8 because I think they worked with you on hotspot itself.
Yeah, I know. I know a couple of them migrated over. I talked to them once or twice. There were some unfortunate, unhappy feelings that I don't know that ever got corrected. 25, 30 years ago, I was forthright with my opinions, which unfortunately for a lot of folks were correct in history, which didn't sit well necessarily for everybody.
Yeah,
so,
I mean,
long time water under the bridge. I bet you things would be much different now.
Our industry does not have a shortage of people with thin skin.
People what?
With thin skin.
Yes. Well, took me a long time to figure out how to deal with that.
Yeah, me too. I was on both ends.
Okay, fair enough. Fair enough.
Yeah.
I don't know. I kind of felt like I was, but maybe that's not true. I was thin-skinned in other places. Around code, I was just strongly opinionated and almost always right. And I could always be talked out of an opinion if somebody had some solid evidence, it was all merit-based, I could be talked out of it.
So one of the ways to enjoy working in a team with technical people more is to learn to categorize things as, I like it this way, but I'd love to see other ways of doing it too.
Yeah. Yeah.
I hate it this way. I did it this way, but I hate it. I need to see something better, because if I knew something better, I would have done it. Like, you basically categorize into buckets of a combination of how attached to it you are, how important it is, how much you'd like help with it, and so on. And then, what you're trying to do is kind of push over into a far, far, far corner of like some fraction of 1%, the things that are actually worth getting upset about. Right.
But isn't this the case with the larger companies set up the other ways to explore for other teams, or persons? So basically, there is a race between the teams who will deliver the better approach. So at a larger company, I imagine that there's some team that will say, if we do it this, we'll save this amount of money, and they said, go ahead, do it. And that basically set up some competing between.
So in the realm of big corps, there's usually some set of projects with one or more champions. The champions sort of dictate a lot of these tech decisions. If you want to see something change, it's a person job. You have to talk the champion into it. If you become the champion, you get to call those shots sort of directly.
How do you become a champion?
Well, you worked at a big company long enough that somebody decides that you're qualified to take on some particular obnoxious project no one else wants to touch.
Most of the time, you become the champion because all the good people leave and you're the one that's left.
Yeah. There's something going on. Well, if that's the case, the company's in real trouble. If
You're
the company's just growing.
I try to be funny.
Well, no, but it's true. You're totally correct, except that they left because there's some shit going down. And if you're any good, you'd have left too. So now, you can become good out of this and get a reputation, but you may not want to be there either.
So you become a champion.
Around. I don't know.
I was only at Oracle for 8 years. Come on, let's not make this personal.
So you become a champion by being the best of the worst.
Yeah. No, that's one way. No, but you can be at a company that's doing okay, and you've been there long enough, and you've made it clear you want some project, or you're excited about doing something, and somebody decides there's budget involved, that you're handed budget, and you get to go to town on it. And
So
now it's your turn to make those calls.
I'll give you a couple of hints that I've, tried to teach a number of people who have done okay. The first thing is, one good way to become a champion is to ask people what they need help with, and then actually go off and do it and come back with a solution.
Yeah.
So when you're the low guy, we have it's idiomatic. So let me pick a different way of explaining it. When you're the new person and nobody trusts you and nobody knows you and so on, the first thing you need to do is deliver something of value to the team. And generally, that's the thing that they don't want to do. So, write unit tests, write documentation,
Clean up the
fix a
build
bug,
system.
clean up a build
Yeah, I was
system.
going to say it's
right?
often tooling.
Yeah.
And what happens is
So
very
you
quickly,
become a plumber. Yeah.
Yeah.
yeah, you start in the
Yeah.
plumbing. And
Yeah.
what happens though is that nobody else wants to do it. So you instantly become an expert on all
Right.
the most important things in the system.
Right.
And then, within a few months, there's a line outside your door of people who have questions and requests for you.
Yeah. Right.
And
The build system
suddenly
sucks. And
suddenly
can't
you've
you
gone
fix it?
from the newest,
Yeah.
least important person to the, unfortunately, to the critical junction point that nothing works without.
Right.
So
And
So,
from
yeah,
there,
I mean-
you get to start reaching a point where you can call shots.
because
This
everyone
one-
comes into a team and they're like, okay, I want to rewrite everything that everyone's done and show
Yeah.
you guys why you're such idiots.
Yep.
And that just, it used to work for some people, but those are not the people who anyone else wants to work with usually.
Well, how about
Flip side of
the-
that, though, is
Wait.
you
I
touch
resemble
it.
that remark. I
Well,
got
I
hired
really
in to do the compiler from scratch.
Very few projects like that, though. Very few projects.
But the compiler is so niche projects that almost expertise you bring in are such a niche project. So most of the people don't feel like they're on your level somehow. Either they resent you, either they try you to credit for your work, they try you to sabotage you in some way.
I got resentment,
Mhm.
pretty big way. And if there had been a sabotage attempt, I was too ignorant to notice it, or bad mouthing. And it was pretty clear that no one was able to take credit for my work. But I know that there was some resentment that went around, and these guys eventually went off to do their own thing. That's where C1 came from. C2, what the hell's 2? Well, compiler 0 was the template jet that was there when I showed up.
Right.
And there was a prior exact VM compiler that people knew needed some major help. And I said, no, I'm going to do this thing that I got hired in to do that makes a fast optimizer I got from my, whatever. Urs Hutzel loved what I was doing. I don't understand. But he said, do it. So I did it. And somewhere within the first year and a half, I delivered. And everyone could see, oh my God, this thing can actually work. And the guys who had been trying to take the template jet and go to the next level with it were so far behind, and we're not catching up, that there was a general vote from the management. Okay, Cliff's the guy, go to town. Well, this got a lot of resentment out of these guys, in part because I wasn't very tactful about their approach. And I pointed out to them fairly bluntly, you'll never catch up. That approach only goes this far and no farther. And that remains.
Yeah, and it's worth pointing out, by the way, that there were a bunch of brilliant people that disagreed with you. And that's the other beautiful thing about our industry, is that we're often working with just freaking geniuses, but they're
So
often wrong
on that
too.
note,
So it's important to kind of step back and remember that if they're geniuses and they can be wrong, always
On that
assume
note-
that you can be wrong going
No.
into any conversation.
But also see benefit that the thing that it was arguing is I can be fast. And that is a empirically observable fact.
Yes. I had a
We're arguing about
measurable-
something that's less observable. The argument goes on.
Yes,
Yeah.
but it's only observable in retrospect. And so what Tidor was asking about
No,
earlier,
the speed,
he's
the
like,
speed is observable right up front. That was
you have to write it first. There's a big bet that has to happen first, a big bet. Your first
you're right.
demo
You're right.
took
It
how
took me a
long
year
to
and a
get to
half
Right.
to answer that bet. You're right.
Right.
Yeah.
And that's a big bet. A year and a half, even if it was just you working on it, a year and a half is a big bet.
It was me and my 2 grad student buddies I hired in.
Right. So that's 5 man years.
Yeah. Yeah.
That's a lot of man years in a company that's,
Yeah. Well,
Trying
Sun
to-
was on the up and up and growing fast. At the time I got hired in, they were hiring in, thousands a year.
Yep.
It was insane, the hiring rate. And I had 2 fresh out PhDs I was bringing along with me.
Yep.
So they were excited for team.
Yeah, but Tidor, you were asking earlier about, don't these big companies, don't they like set up 2 different groups and let them both go and see which
Yep.
one's better or whatever? It's very rarely.
Yeah, that's not right.
Usually that's a sign of horrible management. And I can give you a lot of examples
Yeah.
for some strange reason.
But
of
efficiency is
bad
almost
managers doing exactly that. They're like, okay, I could actually succeed at this if I put all 100 people on it, but I'm going to divide it into 4 groups of 25 and let them each do their own thing and have all 4 of them fail because they don't have enough bandwidth to get it done.
Yeah.
So at the risk of falling into history, who were the 2 grad students and what are they doing now?
Oh, Chris Vick and Michael Plechny. I don't know, because we parted ways unhappily, because at the fail of Sun management, I was still trying to make forward progress on Hotspot and had a long queue of interesting future optimizations to bring to the table. And these guys somehow fell into the category of were frustrated. Like there was a team frustration level, because as a general code quality improvement, people wanted to do like code reviews for everything. And from not having code reviews, because we had gone from a startup mentality to a mature product that big company depended on. And, okay, this all makes good sense. I was prolific enough that most of the other team would be only able to code review my code and do no other work. And as part of the flip of that, I code reviewed every single push from every person that was remotely related to Hotspot, all of them. So, there was some frustration. The people wanted me to slow down or back off or something. But if I looked at the math, I was putting back 50% of all the code. And the next fastest guy was only doing code cleanups. It was John Rose. If you ever meet him, he's a brilliant guy. He's a good coder.
He's awesome.
But he could barely tread water against me. And then it went down in powers of 2 after that. So the rest of the team got frustrated. Now, I bounced ideas off them. I asked opinions. I talked to people. I had my strong opinion or I didn't or whatever. But, I tried to play team member. I didn't want to be the solo head guy, but it's pretty easy to do the math. If I get 10% faster, that was as good as hiring another person. And they couldn't, the other team members got frustrated. So those guys took it in their heads to slow me down on purpose. So my code reviews, my code changes would not get code reviewed by anybody. And so by the local team rules, I couldn't do any puts because I couldn't get my code reviewed. Even if I had cleanups to do that everyone wanted, or I had bug fixes to do or whatever. By the time I left, I had a stack of like 5 unrelated pushbacks to go back that built on each other and brought in new optimizations and cleaned up bad corner cases in the code, did a lot of good shit. No one was doing anything. So I stopped and I did my review of who did what. Oh, and I got claimed that I was causing most of the bugs. And that was the reason they couldn't let me do pushbacks, because they were afraid of all the bugs.
Well, that was probably true. Since
You
were
write most of
of
the code, you write most of the bugs.
That's the trick. So I sat down and I looked at that situation, and the answer was I was in the middle of the bell curve. It was a bell curve for bugs per line of code for new code. but I wrote by far the majority of the new code. And new code had 10x more bugs than technical debt cleanup. It was just like you weren't restructuring anything at a large scale, but you're doing cleanup. And technical debt cleanup had a bug rate that was 10 times higher than bugs fixes, who I counted separately from a partial fix that didn't get the whole bug, from a bug fix that introduced a new unrelated bug, which happened occasionally. It was pretty rare. So, and then other people were like, these were all bell curves at these different rates, but people were at this exponential curve of, I had 10 guys I looked at, so it's not a huge study, but I looked at 100,000 pushes over a 3-year span by a large team of people. Something like, is that right? It was, yes, it was about 100,000. It was a ridiculously large count of stuff. And I flagged everything as new code, tech debt elimination, bug fix, and I counted non-blank line, non-comment, non-blank lines of code. And I threw them all in a big spreadsheet. And I did a bunch of math numbers, and I came out, I am middle of the line for bugs per, bug rate per line of new code. But I write, 90% of the new code. And so that was what you want to do about it. No new progress on the system. And then, I was pretty much middle of the line for everything, including, I didn't do any of the bugs with bugs.
That's what brilliant technical management does for you, is they put together teams in a way that, you're always going to have different personalities and whatnot, and different people who are really good at running off and building something new, and people who are really good at cleaning up someone else's stuff, and so on. And it's like getting the right person into the right role and making sure that they get the support that they need and the appreciation they need to actually enjoy it, thrive in it.
Yeah,
it makes such a difference. And if you get in a bad situation, you can be working with absolutely brilliant, wonderful people, and it can still, the environment can still suck.
Yeah. So it started to suck for me there. That was part of the deal. I was in love with the product. I was in love with the concept. I wanted it to work. And there were some people on the team that I worked well with. That was fine. But those two guys in particular went to basically to the management side and threw roadblocks down. That was very frustrating for me.
So in the end, it's not about code, it's just people again.
People, yeah, it's about people. And sometime later, I started, running the team instead of being also lead coder, but also running the team, and started getting better and better about people interaction. So that was just a practice thing for me that I had not ever done. And, looking back on myself now, I'd have said I'd have been diagnosed autistic of some flavor, high functioning autistic, if they did such thing in Texas, 40 years ago, 50 years ago. So having raised an autistic son who's high functioning, but just antisocial as all hell, I totally get it. So I had my thing that made me feel good about myself that I could do, that made me feel like I was a contributing member of society, and people was not it. So.
Yeah, but it's also just a skill you learn. I've watched you interact with people on these calls who are also having a lot of misunderstandings of the compiler, and you seem to come with a lot more empathy now.
Oh yeah. Well, this goes hand in hand with some of it was stuff I learned. The divorce got me to start looking hard at it and learning. Some of it is skills that are unrelated to empathy, but are just skills that you can learn. You can be trained on these shit. How to handle misunderstanding, how to recognize a misunderstanding, how do you see when two people are talking past each other and not to each other?
Have you guys seen Cliff's presentation that's not technical? Because it's the best presentation he's ever done.
I think I've
seen a salary negotiation.
No, yeah. It's the war of words. Salary negotiation is the draw to bring in programmers.
Yeah, the war of words one. Yeah.
Yeah.
That's a good one.
Thank you.
But it's often the case, the more gifted.
Let me go find a link for that one.
The more the gifted people, the harder they're communicated with. They're much problem with the communication. They're just how should I?
I'll claim that that there's multiple unrelated axes. If you are gifted with people, there's a certain axis you tend to head toward. And if you're gifted with technical and not with people, you end up in a place where your technical skills can shine and your need to interact with people is low. So in our industry, we see a lot of that.
Yeah.
But I claim there are plenty of people who are both highly skilled technically and also have people skills. It is not clear to me that this is an either or situation.
But it's often the case. The more,
I think in our industry, it's the case.
Yeah. Yeah, it's often the case because the more socially, how should I say it?
Call it gifted.
Yeah, the more distinguished engineers start their careers, but they know they are one thing they're good at and they shine with it, but the communication and the social aspects.
Yeah, it's commonly not so good. And this comes not just in computers, but in every technical aspect of the world. You can find similar situations in chemical engineering and civil engineering and every one of these things. And if you're gifted socially, you can often end up in a management role if you happen to have a good technical skills as well, and you decide you want to go there. There were plenty of good social people at Sun who were in management roles for which their technical skills were marginal, but their social skills were good. I claim my immediate managers, that's not fair. My second tier up guy was kind of a dickwad. My immediate managers, I rolled through 7 Daves in 6 years. So, you know, there's one non-David manager. Otherwise, all my managers named Dave, and they all lasted less than a year. And they all said they needed a full year to give me a review to do any sort of, you know, upgrade on, you know, salary or promotion or whatever. And of course, none of them lasted a year. So I never got any of those things either. Fine.
Okay. Next
I've
topic.
had 5 managers in the last 4 years.
There you go.
I currently have 3.
You have 3 all at the same time.
Yes.
That's a
and
bad
I get to meet with them all regularly.
Oh, that really sucks. Oh, you have my condolences. I don't know.
I
Let's
can't
see.
find your presentation.
Hey, Arthur's Bean. Bean still at Azul? He probably left. I think he left.
No, he left like 4 years ago. He got tired of commuting from San Francisco to Sunnyvale.
Yeah, that sucks. He was a good guy. Of all my managers, I have to claim I like Bean the best.
Yeah.
There were
I
some
will
okay
say
guys.
when it comes to management chain, getting a new manager, a new director, a new VP, a new SVP, a new CEO, and a new largest shareholder all in Q1 this year was in.
Who are you working for?
Twitter?
Yeah, I'm about to say, okay, fine.
I had
But
some
the
observation from
Entire
the
chain of command swapped out in Q1.
Yeah, okay.
I guess the CEO change was Q4 last year. So.
And then the sad thing, of course, is that everyone has to bibble bobble around while they get themselves settled. And surely there won't be a good fit after a little while, and some of the in-between layers will get ejected and reset, and it'll be 2 years before you can claim you have a reliable chain of command. And just like, oh, geez. Good luck.
So when you learn all software is about people.
It is, absolutely.
If there were no people, we wouldn't need any software.
Your sound quality is really bad, by the way.
Yeah, I'm not on my usual mic.
Okay.
It's compression artifacts, so maybe your
Bad internet.
Wi-Fi.
Yeah. You're on your bad Wi-Fi. I'll find out about my bad Wi-Fi. My bad cable. Another 2 weeks.
Okay, next topic.
Next topic.
So we are actually working on our first product.
Yes.
6 years in.
You have an execution engine.
Oh yeah, that's not the product though. The hosting platform. So we've actually prototyped our hosting platform, and so we've got you know, with database and web and everything, and all done in Ecstasy. So.
And but you can actually run it. That's what I'm saying. You can run it now.
Yeah, we can upload code and create a host container for it. It's pretty cool.
Awesome.
So, I mean, we're still far away from production readiness, but
yeah, but are you? Well, I'm all about the execution engine right now. So, what are you actually running an interpreter?
Yeah, it's still an interpreter.
Yeah,
but it's
okay.
But that is definitely not the design was not meant to be interpretable, so it's actually a pain in the ass to interpret. So
yeah, right.
It was always intended for ahead of if you will, ahead of time JIT.
Yeah. Right.
Sorry, I'm sure there's a word for it, Arthur, but it's kind of what we were talking about last week. The think of it as a cached ahead of time dynamic compilation.
Right. Okay.
Yeah, I've talked to Gil a bunch about it.
But you've not intended to actually do on the like you're JITting after you know the types for a container, but before you be in execution, so no profiles.
Right. So the initial AOT would be in the absence of any historical profile data, would basically be you know, fast pass JIT that would embed the necessary statistics, first tier statistics collection.
Yeah.
And,
okay.
you know, not too worried about performance at that point, because the main thing you're trying to do is get a baseline set of historical facts on the profile side, just to indicate where to go.
Yeah.
But you know what we were thinking, and is all subject to change, of course, but that, you know, compilation doesn't have to be dynamic per se, because over time you can, you know, we'll be loading and unloading the app 50 times an hour. So, you know, we can do the recompilation work offline, right? If the app doesn't get a request for 10 seconds, it's not going to use, it's going to be kicked out of memory. It's going to be paged to disk. And then, you know, so we always have the ability to, you know, if that's not a safe point, there is no safe point.
Well, I'm just thinking, but that's something y'all have to see how it goes. The thing with the hotspot is I dodged forever and a day the infinitely running loop and just claiming the next time you enter the method, you'll take on the JITted code at that point. And then there was certainly a number of loops that showed up that only got entered once and never entered again, and they were hot. And you had to do mid running loop replacement. So just, you know, watch yourself for that one. Your situation may be a little different. I don't know. Like server loops, which for you would definitely have a breakpoint in it. And for me, I had most of my Java server loops, top level dispatch loop never exited until the entire app exited at the end of the day or never. So that top level loop wanted to get JITted and it had to be mid execution JITted.
Yeah.
The other one that got was everyone who did any kind of micro benchmark always called main, called for I equals 1 to a million, compute Fibonacci, blah, blah, blah. And the next time you called main, you get the JITted version. And of course, there was no next time to call main. So
yeah, there are a lot of ways to benchmark Java poorly.
Yes. Well, I fought all that in the beginning, forever and a day. It's fine. You know, you could be a different situation. Certainly a lot easier if you never have an official restart from the middle of a method. The transitions in and out of compiled code can be vastly easier.
Yeah, I haven't actually worked through that in my mind yet, because, you know, with the interpreted mode, you can always de-opt before you opt. So if you're trying to go from opt to opt and you have a safe de-opt path, you can always transition via de-opt path, right?
Yeah, you want the de-opt so you can get to the interpreter. If you never have any of those except at method entries, there's another shortcut you can take. But if you still,
okay,
but if you still have to have them because you don't want to deal with certain things, that's The other piece that is gruesome is reversing. The really gruesome was reversing into JITted code in the middle. That was the loop that just talking about.
Yeah.
And then the other exit situation that you probably don't have to deal with is code loading, changing the JITted code's correctness.
Yeah, we designed for that one. So
Right.
we don't have the oops, I tripped over a new class file problem.
Right. Now, since we solved the oops, I tripped over a new class file problem, we went ahead and solved for what I call heroic optimizations, which were things that the profiler told us were exciting to optimize around that could fail and were not related to types or code or anything. They're related to data flow, but they were still highly useful to optimize around for.
Yeah, so I think what you were able to do with the dopt approach is to use your dopt as your safe ABI, right? So
Yeah.
you could always revert to, say you had two completely different optimization vectors, right? You could always back down to one vector to a kind of a known layout and then hoist from there into a new vector.
Yeah, if you had different compiler units, as long as everyone agreed on the interpreter, you didn't have to do an n by n crossover. So mostly that had to do with stack frame layouts that everyone agreed on, and the major complexity that you could dodge if you don't end up going both directions is to not go to the interpreter layout. Because the Java stack-based interpreter layout sucks to JIT in and out of. To flip the stack between JITted and interpreted layout. A major pile of engineering to make that efficient and well. So either don't do it or you change the interpreter to be register based and have a stack frame that is fixed size and not variable sized. There's something sensible to be done there.
So this may be changing the topic, but what are the trade-offs around actually making syscalls? I feel like a lot of the new languages I've seen written don't bother with this and just use C bindings when they need to talk to the operating system.
Well, a pretty thin layer over a syscall.
Don't you need to have specific registers or specific locations in memory for getting the syscalls to be happy?
Yeah, you look at the ABI on them, but you're gonna run an instruction, which is basically the syscall it's a protected mode. You throw fault, you jumped in the ring 0, whatever. And now you passed your arguments, however you passed them, which should typically be in registers and then get complicated. So one of the registers is a pointer to a chunk of memory. And the syscall fetched out of user land into kernel land and then validated your args and does this thing and unwinds and blah, blah. But it's just like a...
So do you bake all those into the runtime or?
I'm sorry, say again?
Do you bake all those into the runtime or is that something that gets JITted?
In the land of Java, those go to a native call wrapper first. And then whether that wrapper none of the wrappers go to a syscall. So yeah, it goes to a C, a wrapper to a C. Now the C guy just does like a fucking register shuffle and jump. So it's pretty tiny. But it's one more register shuffle, except you just take a kernel call. So the overheads are already bigger on the kernel side. So maybe, you didn't care so much. That makes sense. Like I've had people who were doing shit like, I'm calling into the kernel to get current time melees instead of calling system.current time melees. They're doing it a lot. Well, that's pretty heavyweight. Okay, the native call overhead actually mattered. If somebody else comes along and says, hey, I'm doing an IO operation. Well, fucking, you got buffer to layer up. By the time you do IO operation, you're expecting a megabyte to go left or right, or at least kilobytes. The call overhead was like nothing. I didn't care. So you could make the native call wrapper care, but you had to have, there was a volume to it. So the native call wrapper was, 50 to 100 clock cycles. If you did a kernel switch, you probably burned that already. If you did just native code to compute a Mandelbrot and the Mandelbrot was a square root or whatever, you cared. That makes sense. Like math.square root would care, except that we knew that. So we called math.square root without doing the full native call wrapper. That was no syscall.
That makes sense. And there's like finite enough number of those that we're actually going to care about with that.
Right. We called them intrinsics, and some of them bottomed out.
You don't have to deal with.
Sorry, go ahead.
I was going to say, you don't have to deal with all, like, here's 40,000 syscalls that the kernel supports. It's like,
no,
here
but
are
all
the 50
those
people
anyhow,
care about.
You just put a signature down, and then somebody generates them. Like,
so why was the square root call a syscall?
no. I'm saying it was not a syscall.
Oh, okay.
It was a native call, so it needed the native call. It would otherwise need the native call wrapper.
Right.
Except that we validated that square root passed the following set of rules, and one of the rules was it cannot block, so GC doesn't care. Immediately, you don't have to have your stack laid out for GC.
Right. So you intrinsified it.
Yes. Yes.
Got it.
But it is a C code, so we call it C code.
Yeah.
But there, the JIT knows the calling convention for Java to Java and Java to C, and we supported 3 calling conventions. Java to interpreter, Java to Java, Java to C, and any one of them could call the other sort of freely, and the JIT would patch it up. And that was a piece of engineering work on the register allocator. That was a stack frame game. But that meant that native calls to square root literally look like the C guy would expect it to look like, right in line in the code. If you got 4i equals 1 to bajillion square root every element of this array, it did the right thing.
So do you remember the conversation we had probably a year ago on buffer management? The
Yeah.
airport analogy, the security line in the airport,
Oh, no.
sending stuff through the X-ray machine.
Yeah.
So that's the project I'm actually getting to work on now, finally, the actual implementation. Not the...
Of an airport security?
No. So no, the idea is with IO. So take NIO in Java, for example. All NIO does in Java is it quickly tells you which buffers have data in them, right? So it's a very elaborate API for telling you what IO can I do using the MOV instruction. That's it. That's what NIO is.
MOV
so for example,
MOV,
when you
yes.
try to move, when you try to select a channel for network read, the network is not involved at all. There's zero network involved with select a channel for network read. There's a buffer somewhere in memory. It either has data in it or it doesn't.
Yeah.
If it has data in it, you select the channel.
Yeah.
Well,
I've done enough NIO to know how the thing works. It's got a well done double buffered start and end, add data, move data, indicate. It's the right API that I grew up with in the land of C guys. Like C guys bought this a long time ago and got the right API out. Then I moved to Java and they had a suck API for performance. It was a fine one for like, ooh, I can call and get bytes. I can peek a byte every time or whatever.
Right, but it was only a suck API for performance because it was blocking in a world where you couldn't have more than a few threads.
It was also suck for any sort of high throughput thing because there was no way to say, you have this much, I have space, give it to me. I couldn't say, give me what you got in any reasonable way.
Yeah, and from Mark and I used to work on a project where we were trying to do actual real zero copy socket IO.
Right.
Which we actually never were able to achieve with Java. We had one copy.
Okay. Oh, that's a good point. I'm trying to think here. In the land of H2O, I did a lot of shit zero copy, but there was always one somewhere for the big data because I had to get that space. I have to look and see again. Fine.
I always said that zero copy just means one less copy.
Yes, that's correct.
But it was useful to get the one less.
Yeah.
Yes.
To purely zero copy don't you have to have a hardware support for that?
Yeah. Oh, you talked to
there's still a copy. Like we were doing zero copy to InfiniBand, but it was still doing copies.
Martin Thompson and doing high frequency network trading, so low latency trading. actually does.
That's where I met him.
Yeah, okay, actually does the zero copy thing with the hardware into user space. Hardware copy data from network to user space. And
so a truly zero copy would be to read directly from the NIO buffer, from the card buffers, network card buffers.
Yeah,
so the card buffers are inaccessible from userland. So it has to actually go via the PCIe bus through what's called DMA.
DMI direct. Oh yes.
Yes, DMA, and then that buffer, in theory, can be zero copy. But the problem is, if you're not fast enough and predictable enough on time, the card will overwrite the data or discard incoming streams. So and then you get a pipeline stall, and so what Intel did is they actually put a Xeon chip on the network card itself with 64 gig of RAM. So you can actually buy a network card. It's a 4-port 40 gigabit network card, 40 by 4.
It's
with an entire server on it, basically. And
on your network card.
It actually allows you to put your code down on the network card. So you're basically handling the packets as they're coming in. So
it's like on Flare, solar on Flare or something.
Yeah, yes, you're in the right space. It's been 6 years since I've worked with it for some reason.
Right. And then he Martin Thompson does this disruptor thing, which lets him do very, very low latency processing, and so he can keep up. But if he has something he can't keep up with, he can move it quickly to somewhere else where the buffer can
so his
grow.
goal was basically to always have an active reader and an active writer, and never push the stuff out of L3, I guess you'd say. So in other words, have.
Does it land straight into L3?
I don't.
To go to memory once, then go to L3.
Injecting.
Yeah.
But it's basically a ring buffer he was using.
Yeah. Yeah. And as long as you stay ahead of the game, it's all good. I played the same ring buffer games in H2O or something similar, and the answer was, of course, if you ran it out, then you got a Java out of memory error because you ran out of the NIO buffers.
Right.
But if you were keeping up, then you would just recycle the damn buffers. And he had a.
So Mark, sound familiar?
Yes.
Since so Java, Java has very hard edge conditions when you, for example, GC, how GC interacts with the direct byte buffers is horrific.
Yeah.
It's more like that it doesn't interact with them.
Well, it will occasionally, eventually, maybe.
I was always doing batch throughput though, so I didn't have to do a latency thing. I shouldn't want to run out. But say if you're doing latency and GC kicks in, I don't know what the newer GCs would do. I'm not talking about these old ones. I'm talking about the old school collectors.
Well, the main thing is you must never ever let go of a direct byte buffer.
Well, you can't rely on the finalizer.
You can't rely on GC and you can't rely on finalization, right?
We grabbed them. I want to say that I watched that list, and if I had too many unused for too long, I would do the explicit deallocation call they had,
right?
Which would bypass the finalizer and get it like returned properly.
So it would only return a native byte buffer. Mark, correct me if I misremember this, but on the second full GC. Something like that.
I know you had to at least get to, well, it was that they could get cleaned up on a minor GC, but they tended to live long enough to get promoted into tenured, and then then you had to wait for a full GC. And you're right, it may have taken 2. But I think
you're generally flipping them between 2 threads, right? So
as soon as you're going over the network, you're getting tenured.
Yeah.
So, and I think where we landed, and able to be able to actually throw them away, was we were only willing to throw direct byte buffers away once per GC cycle.
Yeah.
So that was it's like, if we could see that a GC had happened, then we're like, okay, we can throw away our garbage, but we're not allowed to throw any more away until the next GC cycle. And then that would kind of balance things out.
Oh, I see. Oh, that's interesting. I didn't go there.
So we could grow during a cycle, but we weren't allowed to throw anything away during that cycle. It's like if you need more, we need more, and that's fine. And then and if you witness a GC cycle and we let ourselves clean up. So there was always still waste in tenure, but the amount of waste was contained.
Right. I'm trying to remember when I threw them away. I totally watched the thing. There was usually like a big spike during data operation, data load of some kind, and then it would settle out while you're doing sort of normal crunchy math, which would typically, you know, between seconds to minutes. I didn't play that. I played a bunch of GC games, but I don't think I played that one. Like I explicitly deallocated them because they were, when I let them fail on their own, they wouldn't, as you pointed out, and then you get out of memories from NIO buffers. And I had other full GC cycle issues, but I got full GCs probably more often than you guys did. So it's the old school collector. Most of the data was in large pages, not moving and not going dead. So full GC cycles on 200 gig heaps would be a couple seconds, 1 or 2, and they would come around, you know, every minute or less. So I had them enough that that as long as I didn't have a spike of IO issues, I was fine. But I had
we didn't have control over our production environments, so you know,
right.
There were customers that had few and far GCs, few and far between, and then you know they got bit by the direct byte buffer stuff until we managed to link it up to the GC cycle.
Right, that makes sense. I was watching my giant data sets from the GC cycles and would decide that you were about to do a calculation that was going to not work. And I would unwind the current calculation in progress and free up all the memory that was being temporarily held for it. And to make that live by catching the fucking out of memory. There was an out of memory handler that I would catch on all large allocations, not small ones, but the large ones. And if I threw it, then I would throw away a spare megabyte that I had kept just for surviving these things, and throw a bunch of buttons, push a bunch of buttons that said stop, 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 and then, you know, toss everything you're doing temporarily away. And usually you couldn't run your megabyte out with controls before, you know, you were okay. But it would be the case that like 10 or 20 threads would simultaneously throw out of memory, all in the middle of trying to allocate the next 1, 2, 3, 10 megabyte chunk that they were going to allocate into, and all off time for each other. And so the 1 meg would get freed for the first guy who died, and then 10 more guys compiling in also dying. And they had to also, you had to be race fucking safe in your out of memory recovery and stuff. Never mind. I don't know, the systems where they work reliably with limited resources and you handle the I'm out of resources reliably, that there's some serious hard work to make that go. It's one of the things that the language, none of the languages I ever worked with carried support at the language level for that. You know, Erlang would claim to recover from the crash, but it's a resource limiting crash. It wouldn't necessarily get, you know, recover sort of gracefully at some particular point. Like all of these things, you had to do like an atomic transactional mindset about them. This transaction was going to proceed and complete, or it stopped half in the middle, completely unwind and say, I never took it. Because if I take it, I throw out of memory. And that was trouble to make that work.
Yeah, Erlang would carve out a significant portion of the system and just flush it and then restart it.
Yeah, and hope that the flush would then garbage collect and clean up enough space that you could go again.
Right.
Right, and then you didn't leave any poison. You had to have, you had to have a safe point in your application, called a safe point, where you could roll backwards and say, here is a good spot. And as you said, you carved out a chunk and threw it away. So you've got them baked into yours. That's what Ecstasy's got there. So it's a reliable place that I can carve out a fail mode. Boy, somebody comes and goes their video and then the screen reshuffles and I'm looking at a person's video and then like, oh, they're over here. Oh, they're over here. It's fine.
Okay, we are searching for a next topic.
Yeah, it's Mark Falco changing his background.
Sorry about that. Just trying to make you dizzy.
Yes. Yes.
So for an A, the type system work, do you fully implemented what you wanted to? Or
I think so. I kept adding things that looked like they should work and be easy, and intuitively something correct would happen that later the theory would say, no, actually you had to handle this. So I've gotten an ever more largely populated case of type theory testing that's more aggressive about things. That sort of topped out, last couple months. And I mean, in the last day and a half, I took maybe the last thing I'd ever seen that I added in. I thought this will be easy, and then proved to myself that I had the right properties, and it turned out I didn't, and I needed one more bit. Here was Mark one more time. So at this point, I think I have test cases that implement entire type systems in small and as an unrelated, like I have multiple independent implementations, and they're showing that they have all the right properties for the complete set of what I want to do out of AA. So the last go around happened because I decided that I'm going to have all my primitives type wrapped like a big integer, but only in the type side, not in the implementation. So 0 overhead wrapped integer, which means I can go to an integer and call the .hash function on it, and it'll give me itself as its hash code.
Why the type system should be concerned between a capital integer or a primitive?
Well, because
integer.
It's memory or not, and memory, like 2 capital I integers of the value 1024 are not interned, so they'll be different pointers. So they'll be pointer unequal. So in my world, equal equals will say not, and dot equals will say yes. So you have memory state, you have allocation, and you have the ability to make changes, except the fields are final and stuff. So I'm tracking memory separate from values. So I have reference objects. If you're a value object, you don't have a reference identity. And if you're a reference object, you do. Okay, so integers don't have a reference identity. So that's the difference. That's why it's not a big integer. Okay, now I still want to do lookups on the integer like it's a standard object to look up their hash code, their .eq function. Maybe there's some pretty print, convert yourself to an ASCII string, or be a bijection from an ASCII string and back and forth and that kind of shit, right? Okay. To do that in the land of where I was sitting in my type system that I've all sort of in the language implementation, there's a thing that says, I know the class of this guy. I can do a lookup on final constant fields that I have moved off to the side because it's a final constant. It doesn't need to be in the main in every instance of an integer or any user object. So all your class descriptions for me become assignments of functions to final constant fields. Because it's a final constant field, it doesn't have to be a function, but because it's a final constant, I move it off to the class, if you will. It's not quite a class, more like a prototype. And now I'm weaving that through for the integers. And that had been well along when I realized that the not implementation, the bang, wants to take in something and return out a nil, or take in something, return out the integer 1, which is fine, except I end up mixing nils and wrapped integers. And then I realized I didn't have a type system semantic meaning mixing what I would call a scalar value and a struct, which happens to have a field, which is your integer. So the integer has the struct has one field, has the number, whatever your integer value is, 17. But because it's a struct that has a named type on it, I can go find where do all the other fields as a, internally as a speed code optimization, size optimization of all your final constant fields have been shoved off to this prototype off the side.
You moved them from the object.
I wrapped all my primitive ints. Then I discovered that they look like structs to me now. Okay, now I discovered that if I mix a struct and certain scalars, in the past I had just said, that's an error. Now I want to do something meaningful. So I went to, here we go. I even have this sitting hot and ready in my fucking buffer. I'll do a screen share, and we'll show you the madness that just needs a little bit of No, wait here. Oh, screen share. Yes. Yes. Okay. So here is a lattice demonstration. There's an outer lattice on the right in the orange box. There's a struct that says struct at C equals. That's just, here's a field, a struct with one field. How do they interact inside the struct and outside the struct? And previously I would have said, if you had mixed an int with any of these struct things, I'm just going to fail you out to bottom and say, error. And of course the language just disallows it. Now I'm saying, oh no, I can have a nil and it can flow either in or out of the fields inside the struct. So I could have an if then else where I blend a struct and a nil, and I'll give you a sensible type theoretically correct answer. And then it's type safe, and I can analyze on it, and I can work with it, whatever kind of thing. So sorting out those edges, especially where the nil and the twiddle nil, the X nil, the high and the low nil cross in and out was not obvious. I didn't have it correct in all contexts. I sorted this out, last week, but like I said, I worked a day and a half total last week, maybe for moving the rest of the time.
It doesn't the looking inside the struct to see if it's an integer, so you can equalize and somehow doesn't go a step too far?
Right. So I could do a couple things. I could say I have a special case for integer structs only, structs that I know represent an integer, and they specifically understand how to handle nil, and no other kind of struct does.
Yep.
But then I have a bunch of special case code where I say, if you're a struct that's a nil struct, oh, a nil struct's not a normal struct. A normal struct and a nil struct are two different things. I have to have them separate in the type system. You can't blend them or mix them accidentally. And I end up with two implementations for them all. Okay. And you could argue the same thing for floats, but it's less important. For nil, it's kind of important. So I said, well, can't I just do this for generic structs and not just for specially integer structs? And I tried. I thought, oh, this will be easy, and I did it, and then it was wrong. And I tried some more and tried some more, and I said, wait a second, okay, back up. Now I know how this fail goes. I must go to a very simple test case in the theory and do it from the theory side. So let me stop this share and start another one. Actually, I can probably now just do it here. Screen share. Okay. Let me go. Let me make my font bigger here. Okay, is that like readable more or less?
Yeah.
Emacs is like confused as the window size. Okay, fine. So here is test names as of last week, this week. It is an implementation of my struct class that is only this and has no other relationship to anything else, doing shit with like a hash map on the inside, which I wouldn't otherwise do, because I want to have the easiest possible way to go do things. And I added and removed fields and screwed around, and suddenly I passed all my tests. So let me go down through the testing side at the bottom here. Test type, what does test type do? Test type says, take the set of tests in SS0, here's some tests, this is some new S things, here's a couple of these guys. Some point object, here's the point object right here. It's got an X and a Y field. It has some other shit going on, but it's actually X and Y. It's named point. I have a named int right above it. Here, I'll reset a little bit. Here's a named int right above it. Okay, so I have some mixed structs. Some that look like integers, some that look like points, some that look like empty, some that have other things in them. Like STD here has like pi in it, shit like that. Okay, take these guys, assert something sensible, grab their dual, so everything has the inversion relationship. Also take a bunch of scalar types like scalar, in scalar, nil, and their duals. So in scalars, any scalar that's not nil. So everybody who's not nil. So this is the nilable test. I can tell if you're nil for everybody. Then run this test that says, are you commutative? I'm going to recenter. Are you commutative? Are you associative struct to struct? Are you associative struct to scalar? That's the test I was trying to exactly get. Are you symmetric? If you pass all those, then I'm happy with you. Okay, well, commutative, let's go. Commutative is super easy here. Let's go find commutative. Commutative, I meet you. I meet you the other way. This meets that, that meets this. If those two are equal, you're commutative. Ding. Okay, that one's not too hard to pass. Associative is a bitch for a long time. That is, meet S0 and S1 as two different structs. Then you meet that to S2. And alternatively, meet 1 and 2, and then meet that with S0. Don't lose, and they're equal. So you don't lose anything by doing meets in funny directions. That one took a long time to sort out. Here's the same meet with a scalar, which is I can meet nil into a struct with another struct. They're inverted high, low, in any order, and I don't care. And I get the same answer. And furthermore, the answer happens to have nil meet in it, so it does something useful with nil. The other way to solve this, of course, is have nil and struct do nothing useful, like, hey, it's always bottom or scalar, and then nothing. And symmetry is this horrific thing that says the lattice is identical up and down. And you can read the comment there. If A and B, that's meet. If A meets B is meet, then dual of meet and meets with dual of A is equal to A, and dual of meet and dual of B is equal to B. These sets of properties gives me that my lattice is associative, commutative, distributive, symmetric, complete, bounded. It's not bounded, but I got bounded from other things. Okay, so I did that because I was having issues with names and nils, and I sorted the names out and I sorted the nils out in this standalone thing. This was like this week, last week. I had not everything with where I didn't meet nil into a struct was working fine. And then I discovered that if I wrap my primitives, I really badly wanted nil and structs to mean something useful together. So I had another go around with the theory set. And that's what this guy is. I scroll up the implementation here. So I'm back at the top. I fill in a name, which is like your class, if you will, a flag saying the name is high or low. That was the weird one. A default field. So semantically, my structs have every possible infinite field. All of them, all the time. Most of them are set at the default value. So the implementation strategy is there's a default that is all the not named fields, and the exceptions are listed in this hash map here. Because semantically it acts as if they have all possible fields, I can prove interesting properties that work in all cases about them. And I just have to show that my implementation when he's done blending shit, approximates back to single default and a list of exceptions. So all these things do is some assert that you're not handing me a field that you're the default, because the default's supposed to take them all out, and that's the canonicalization. Set the fields, fine. If you're a dual, pre-compute the dual, because compute duals all the time. So if I call dual here, it's just a field load because I pre-computed the duals. There's get, which says, look it up in the hash. If I miss, then go get it out of the default. That's this one actually here. This other guy went back and forth and said, I don't use this one more. This one's dead, I could throw away. I was trying to do something with name fields. That was an experiment that failed. So I'm thinking this get is not being used. This get is sensible. This test is not being used, but it does a hard is-a by doing fields in both directions. A struct, this struct is a that struct if every one of its fields is a that field. Where I was getting my fields based on the field, the class name had to match as well, and I ended up not using that. This is a meet zero is a print. Prefix and meet, here's the actual meet implementation now, which is walk all the fields on the left-hand side and put them in the right, and put them in the common guide. So build a common hash map, walk fields left and the right, walk all the fields right from the left, do a meet both ways as you go. A bunch of fields are common. If they're in common in both, I end up meeting them twice and just shoving the answer once into the final guy. Meet the defaults, remove all the duplicates that match the default value, do something fancy with the prefix, with the class name. This took a while to get right, which is if you have two classes, they have a common prefix. So I have object is subclassed by number, subclassed by integer, and I have double, which is also subclassed of integer. The least common ancestor of those two is number. That's all it's computing here. It's least common ancestor in the tree class hierarchy. Except that I have to do something smart about whether you're a high or a low, because it depends whether I can keep the longer, integer is a number. Do I intend to keep integer or do I intend to keep number? It depends on which way I'm looking at it. So that's what this game is. And then the last line here says no common prefix, fall hard. That says, oh, I'm looking at integer and animal, and they had nothing in common. So you get wiped out.
So this computes the similarity between two structs. So
yeah, it's the meat. So you could call it similarity. Yeah.
It will give you, it will give you between two classes with different fields, what's the common fields between them. So if you can generalize it to some int and scale, so it will give you the most common substitution, if you will.
Right. And now this guy in particular keeps fields separate from classes, so that if I have a code that works on an X field, he'll work independent of your class. But if you want to demand a class, I can go check it. But you can write code, so it's more like an interface. You can write code that says, I know how to do X and Y and compute distance from X and Y. Whether you're called point or you're not called point, I don't care. If you got an X and Y field and they're both floats, I can compute distance on them.
So we will ignore the names. We'll just look at the types.
Yeah, that's the version of things that looks structurally correctly typed, structural typing, strongly static structural typing.
This is supposed to
this
is in the structural. Yeah, this is it's already in the structural types.
I can do nominative typing and I can do structural typing, and I claim it should be pretty easy to pick which one you want and choose back and forth.
So this is kind of the CSS and the HTML addressed by index or addressed by name. So you have to pick which one you want.
Yeah.
Do you want to stick to the name? So it's kind of interface, so name it interface, if you will. So, or you want to stick to the types. So anything that can fit in this type can be made this type.
Yeah. Yeah. Yeah, there's some
and this
can do here. Yeah.
This can surface all the way to the user, to the language, to tell the user what does it want. Do you want to do the index of the types with the names, or just the types, or just the names? So you can mix and match.
You can mix and match at the user level, and it's type theoretically correct. So there's a strong, well understood semantics for how the mix and match works. And that's the trick, is getting the strong, well-understood semantics for mixing.
So this goes the way, even in, this is, I believe, is how the way of subtyping, because you can do pretty much all the things.
I support standard subtyping with this. I support interface-like behaviors, row polymorphism as well.
Yeah.
All of them in sort of anything in between with strong, good semantics. There's no holes in here. That was the whole game. I effectively have a fucking algebra. I have to look it up. I don't have the right word for it, but the type, because it has all the properties it has, it's some special thing. I want to say it's a Boolean algebra, but it's not quite. It has certain properties that are well beyond what you'd expect.
This will be a pretty strong feature of the language.
That was the goal. Yeah, right. Yeah.
So you have to minimize the weirdness.
Yeah, at the language level, I want to minimize the weirdness. But the typing level, if you only do C-like typing, you'll get C-like typing behaviors. If you only do C++ or Java-like typing, you only get Java-like typing behaviors. If you start to mix and match, then you get into zones where it'll make sense if you think about it, but you have to think about how it means, but you don't have to go there. So that was my last week of sorting out the last corner cases for typing, because I added a new feature. It does mean I can ask a question, is this struct nil? And by which I mean, are all fields in the struct nil? And I have a semantically well understood answer for what that means, which means if you have like a pixel object that has RGB colors, you can ask, is it nil or not? And directly on the whole struct, and the semantically has a well understood meaning, and it means, are all the fields nil, 0?
This feature, you can push it it's a powerful feature of the language, and
I hope so.
Yeah.
No, I don't know if it's useful, but
for example, if you give it a block of code and you can say it compute me all the interfaces you can make with the block, it will compute all the structures of the code. You can make some kind interface to interface. You will ask the question give me what interface can this code implement, and it will give it, because this is kind of in the same ballpark.
The type inference will take a function and tell you the, what do we call it, most general type of what it accepts.
The principal type, the principal type.
Principal type. Yeah. And including, I've done it with recursion, and I'll find you the field names of all the functions. You hand me some set of structs that have all the following fields in them, and they have types for these fields. I'm good to go. It's all great. Including cyclic, recursive, loopy things and shit like that. Yeah.
Why would you call that is null as opposed to like is empty or is default? Feels like it may be a different concept than null. Your struct where all of the values are the default value.
Yeah.
It's not clear to me that that's the same concept as nil. That shouldn't be like is default or is empty.
So there is another corner that has to be that I could go either way on, and I chose one way, and I'm all happy to go the other, and that's if I have an empty struct, is that nil or not? And then hand in hand, the empty struct looks like every other empty struct. There's only one. And hand in hand, there's the notion of, hey, all my fields are the default, but the default is not like X scalar or scalar. There's these things where the default, all fields are default, and the default is the error case. That's a common situation. That's, it's not a useful struct. No one can do anything with it. It's not like you made a new object, capital O object or anything. Then I have a struct.
I mean, I guess I do have cases for like day of week, or I don't know.
Yeah, that's my intent for nil showing up in a lot of cases is I don't know. That's the usual people have for a nil is I don't have one of these, or I don't know what to do with it. I wasn't originally intending to have nil and struct meet in the lattice. So nil was referred to a reference object, like a pointer to a struct, which could be nil because I don't have a person at this point in time. I haven't computed one yet, or I don't know what it means or whatever. But now I can make that same question about a value object that is a struct. Whereas on the integer side, nil means the integer 0. Or I'd like it to mean the integer 0, which means the primitives all can eat a nil as an input, and they will treat it like an integer 0. They'll convert it to an integer 0 internally, do something with it. So shit like Boolean and will take a nil and do something that do something sensible with it.
I don't know. It seems super not obvious to me what the long-term consequences of having or not having that feature is to software design.
Me too. Yeah, exactly. So at this point, I'm like, well, I have to try it and find out. Once I've sorted the theory out, the implementation kind of moseys along afterwards. If I'm not moving, the implementation's been done. And it's going okay. I'm basically I killed off all my primitives and I'm resurrecting them all. This morning, that's what the job was. I'm in the middle of sorting out what does it mean when you have a nil show up on a wrapped integer struct, whatever. I'm dealing with wrapping and unwrapping in the primitive math. Add a wrapped 2 and wrapped 3 gives you a wrapped 5. Well, I have to unwrap and rewrap. So that's all just going in right now. Actually, that's all done with the prims. Which is this one? This is my, this is me. This is the unresolved guy. I'll have to look. Yeah, it's pretty far along. I'm getting into the cases of non-primitive nodes, and I turned a bunch of things off on them. So they just threw an unimplemented and a big comment says, fix me now. And I'm in the fix me now stage for these things. And unresolved, I have a node called unresolved, which does a typing time resolution, or you have an error, ambiguity error. And I'm not certain that, I know what it's there for. Shit, yeah, I still have to have it, okay. It's like you looked up an operator plus. Well, there's string plus string, there's int plus int, there's float plus int plus float, float, whatever. So those all go to unresolved, who's waiting for the types to be known for the first argument to do the lookup. That's fun. You know, I think I have a day's worth of screwing around, and I'll be back to running my little tiny AA test cases and start making sure they all behave as well. And again, I think they'll go pretty quick, but it'll be because the move is like here in my face, you know. I'm gonna be not much progress for a little bit. Fun stuff.
Definitely, it will get interesting with
Yeah.
more of the tests, more of the language if you envision it once flesh it out, so people can play with it.
Yeah. Well, I need to get it to where I can run even a little bit, and then people will just pile in because they'll go, oh my God, you're like, wow, this is cool. It's cool. What the fuck can we do here? Because I would pile in like, hey, what does this mean? Okay, let's write some code. Hey, this is funny. Look at this. Look at that.
I will say I did give up on my attempts to get it running on a ARM32 Raspberry Pi.
Because you didn't have a Java 17?
Yeah.
Yeah.
There was an ARM64 Java 17, but I didn't see an ARM32 Java 17.
Oh, well, it should be a 64 should be fine. Why is 64 not going to work for you?
Because it's an old Raspberry Pi.
Oh. Okay, fine. Yeah, I jumped to 17 from 8 because
I think my conclusion is going to be to go back to an x86 CPU.
Right. Well, right now, if you run the first AA test, so the test names is a standalone guy. The first AA test is the test parse. He'll just choke immediately on an unimplemented, which is where I'm at right now. Actually, I'm running my test types, general AA tests, which are almost done. This last guy, and he actually builds AA graph and starts to execute on it, which is why I'm now in the execution side of things, and he's choking. He's the last one of the test types, and then I'll be doing parsing the AA structures, which they do real AA code. Fine. Thought I was going to be there a week ago until I hit this particular nil struct game. Yeah.
I don't know. I find a bunch of those tricks to make the model cleaner for implementation can often make the model cleaner for actually thinking about it. Good.
Yeah, that was my theory on this too. One less corner case in the universe. I got rid of function names. It's just another field. I got rid of, there's no top level function names. There's just fields. And the top level variable names that you would put your functions at, like main is a function of yada yada, is just a field in the top level guy who exists as a standard, execution frame. He has variables, he's assigned main, and life goes on. And that seemed to me to remove yet another corner case.
It's funny that I end up making almost the exact opposite decision as you in every case, because we got rid of fields by having functions.
I'm sorry, say again?
We got rid of fields by having functions.
Oh, but you got rid of fields?
Yeah.
Okay.
So if I have a class within X, what it means is I actually have a function on the class, say it's class C. So I have a function called c.x, which returns a new object, not a new allocated object, but it returns a reference that itself has functions for accessing and mutating the value of X.
Okay.
And
so how do I know that you don't give me a weird version of X when I ask you for its height rather than giving me back an integer fires the missiles?
Ask that again.
I got it.
If all of the fields are now functions, how do I know you're not going to give me a weird implementation of something where I think I'm just doing field access, but I'm actually mutating state somewhere else in the universe?
What's the cost model?
Yeah, I mean, there's that is certainly a possibility. Yeah, so it does allow any access to what Cliff calls a field to be indirected via even virtual. Yeah.
Right. So I claim I have cost model that I went down the path of I wanted the cost model to be obvious. So you're guaranteed that you get a field-like cost model. And at some point, I'm going to give you a guarantee of field-like shared memory semantics. For which the Cameron's world is different. There is no shared memory. So he doesn't have that situation.
Okay. And on the cost, I mean, we had a different. Again, it's not really opposite. It's more 90 degrees than 180. But on the cost model topic, we chose the approach for the reason of the cost model, but with a different optimization goal, which is 99.99% of properties are fields, right? But how do you know that until you can close over the type system, right? So once you've closed over the type system, so in other words, think of the type system as a bunch of piles of spaghetti that you put together in a pot, right? And think of closing over as visiting each strand of spaghetti individually, right? So you visit, you can think of it as a visitor pattern over the types that exist inside the pot, right? So you have all the types in the pot, you check them all, and you see, hey, this property has no indirection. Therefore, when I compile code that accesses the property, it's a move. Well, it's a EAX, the
x86 instruction is not important. The important part is you have a field-like semantics, which goes to a field-like cost model. And then the optimizer does common sub-expression elimination and hoisting the registers and all that kind of shit.
Right, exactly. But it's only knowable, it's not knowable by the compiler in the sense that we use the term compiler, which is the compiler looks at the source code and spits out something in IR, right? And then later, it's not, if you look at that IR, you can't prove or disprove anything because it's only one pile of spaghetti. Until you mix it together in the pot, you can't actually prove or disprove anything.
Yeah, I decided the fields, I wanted the user to have a hard proof that it was known cost model and semantic. And there are other portions of my type system where I have to close over to prove things. Right. So I don't know, A calls some unknown function or where it's an incoming argument gets passed to me, then I call off of the incoming argument. I don't know what the hell I'm calling there. And so inference has to have the solution closed over at some point. Type inference has a limit to it. I guess the real limit there is to do partial compilation, you have to have types given at the module boundaries or at some boundary case. So you would call a service boundary. There's types.
You can end up in the case that the function, all of the function calls some fields and this function calls some other fields of this. You have to meet them together or something like that in order to extract at the end function what it returns, for example. Does it returns a field of the object or some kind, a substructure of the bigger structure? That can become a problem, at least to me.
It's not clear to me how first class functional is XTC as XTC, Cameron. First class, I can pass functions around and do anything.
Yeah, true. Yes.
Okay, so functions that reference multiple different properties set in other modules, what do I know about what I'm getting back?
You know the type.
Okay.
I mean, it's statically strongly typed, so
okay.
You always know the types.
But you can't statically know the implementation is a field reference.
Right, because a parameter of the function could be a type that has subtypes. And because of that, you don't know, because think of it this way. Everything is virtual. New is virtual. Property access is virtual.
Right.
A function call itself is not virtual, but methods are virtual. So we have methods properties, classes,
Yeah.
everything's virtual.
I got rid of methods separate from function calls too.
Right. But virtual sucks. Right? It's great from a development perspective, but it sucks from a performance perspective. So
Right.
what you want is at development time, everything to be virtual, and at runtime, nothing to be virtual.
Right.
Right.
And
so,
what I want out of that blend is to be able to name things somehow such that I know it's not virtual. And then let the optimizer clean up all the things that I don't care about.
Right.
There are times when I want to say you have to not be virtual, and I don't know how to do that in Ecstasy. It was one of my goals for my cost
You
model.
wouldn't use Ecstasy. You wouldn't use Ecstasy if that were your goal.
Okay. All right.
No, I'm like, it's not supposed to be the answer to everything.
Yeah, fine. Okay. Yeah, no, it's
So
fair
it
enough.
sounds like
fine.
in Ecstasy, there's no distinction between a function and a closure. A function is just something that doesn't happen to close over something. In AA, is there a distinction? Can I, in the type system, say I want to take a function that is not a closure, or are they the same concept?
They're semantically, they're going to be the same. And then I'm going to have a runtime type property that you can add on that says, I must be able to, at typing time, guarantee that this turns into a function.
So Aaron, ours is even worse than you said. Not to use the word worse in an insulting manner, but
More general.
Yes, because what Cliff was talking about before in terms of the service boundary, so a function can actually hide a service boundary as well. So I can call a function, and not only is there the potential for having closed over something already, but it could actually represent a service transition as well. So permeating.
But that's just like a function call doing an RPC more.
Yes, that's exactly right. Which if you think about what you just went through in terms of knowing exactly what something costs, tell me exactly what maybe RPC costs, right?
Right.
Maybe RPC is not something you want to see in a cost model.
No, it is. Or I think it is.
What I meant is if you are looking for absolute predictability, you don't want maybe RPC to show up in the list.
Right. But I want to be able to say something to the extent of this call makes no blocking other calls. And recursively. Right. I'm doing the GUI piece. I want it to be reasonably quick, reasonably reactive, no blocking calls. That's a type annotation that goes recursively down. And I'll allow, you could say blocking calls means or allow new allocations or whatever. We can argue what it means to block or not in various contexts. But there's some version that is a property that is going to be lexically scoped that has to go through call sites. So I have to close over the entire reachable call graph that I want to say something. And then they're all have to do with performance. This function does no auto boxing. It can allocate
so
when I know it.
It's kind of like what they talk about with coloring your call graph.
Yeah.
Matt or Tudor, do you know the
I know the reference you're talking about.
Yeah.
I'd go,
but that's more async sync, but it's still the same concept. Right?
Yeah.
Like,
Yeah.
I think that's
what color is your function, I think is the name of the blog that.
Oh, I think.
Yeah, you brought it up once, Tudor.
Yeah, I'm
Yeah. I think I'm.
okay. Here we go. I got a blog. I don't claim it's the correct blog. I'll put it in the docs here. Found with 30 seconds of Googleating and had the right keywords in it, but whatever.
And if you follow the rabbit hole far enough, you come back out at that Microsoft blogger, the Miata or whatever it was called.
Oh, you mean Herb Sutter?
No,
No.
no, the guy that worked on the language that they killed. But Joe Duffy, maybe?
Oh, Joe Duffy. Oh, maybe.
No,
I think Project Midori is what you're trying to reference.
Midori, that's the one. Yeah.
We should throw a link in the chat, somebody please. In the chat.
Although I believe the Midori project was the language M#.
Yeah, so Joe Duffy.
I believe the Midori language that ran on the C# VM was M#.
Gotcha.
Because he's the one we brought up years ago on the error model blog. I'll paste that one.
Yeah. Well, that was one of those models was like the big takeaway for me was admit that there are errors that are going to fail hard and fast. There are some you can recover and some you cannot, and don't try to recover the ones you're not going to recover anyhow. Instead, just hit the debugger and claim you got a problem to deal with.
Yeah, it's a great blog, even if I don't agree with it, all of it technically.
Yeah, there's some things I
stuff to think.
didn't want to agree with, and some things did, yeah.
Well, it's a question with no right answer, just a lot of wrong answers. So it's a question of, can I dodge most of the wrong answers in my design?
Yeah, yep. Yeah, range check out of bounds exception. They happen. What do you want to do with it? How many people can usefully catch and recover? Not so many. Why bother? Okay, fine. Certainly in the land of multi-threaded Java, people would try to catch range check out of bounds when they parallel insert into a single threaded hash table and to claim that I only had one writer and many readers, and occasionally a reader would throw a range check out of bounds exception because the table was mid resize or whatever, and I'll just catch it and try again. And of course,
I don't know whether that's scary.
Yeah, well, this was in one of the big web servers. There were several big web servers at the time, JBoss, JWebSphere, and a third one that cheated in funny ways. One of them was I took a hash map, not multi-threaded safe. I had one writer and many readers, and occasionally a reader would catch halfway through a write and get a null. I catch NPE and I just go again. I didn't have to synchronization cost. Much more rarely, I would throw an array out of bounds, and I had to help the guy understand that one. And that would be mid resize of the table. And all I had to do was go again. The reader grabbed the new larger table. The writer was busy reading from the old and writing to the new because he was resizing the table, and the reader used the old table and the new bounds and died. But then there was a third fail mode, which was, go ahead. The third fail mode is
a lot of web apps really want that concurrent hash map, or the performance is sad.
I just saying, back in the day, your options were lock or not. Concurrent hash map wasn't a thing. These guys were like, we're not ready to go to a concurrent hash map, even if it's around yet. We're just going to do it this way. So the last fail mode was the reader decided the table was too dense and he needed to grow it. The writer was also growing it. They were arguing over growing how to rewrite the table. So they would stomp the linked list chains because you're regrowing because you got one long chain. They would stomp it into a closed cycle. Then the reader would go again on the rewritten table, go to that bucket, run down the end of the chain looking for hit, just hit the cycle and spin. And he'd spin and he'd spin and he'd spin. The server on the outside would say, oh, this transaction appears to be hung. Let me kill it at the transaction level and fire another one off. Well, that thread wouldn't die, it would just spin. But you take another thread and it would do the transaction to be okay. And then some other guy would come along with the same guy and hit that same table, go down the same linked list and hit and spin. And you have two threads spinning. And then 3, and then 4, and you get a new thread spinning every server transaction timeout. So
this is a core. Just check off a core. Check off another core. Check off another core.
Well, soon they're all busy. So you get 50% of a core, and your server throughput just slowly runs downhill on an asymptotic curve with this set of transactions, all the same one, all eating a core every time. And eventually it runs to a halt. Now, all you do is reboot the system. It comes right up. It's all great. Server's fine. So as a performance bug, it was a nightmare to diagnose. It was ugly. So I had to whack some developer on the head for doing that one. Said, no, you cannot.
Well, synchronization was expensive in JDK 102.
Yeah, and it wasn't really cheap at 1.2. And by the time 1.3 came around, the JIT was fast enough. Synchronization was kind of relatively expensive. And everything lifted, the rising tide lifted all boats, and synchronization was still a boat anchor carrying you down. So it got expensive again for a while. And then by 5, it had both gotten cheaper by a lot, and now there were options. But there wasn't a concurrent hash map that was ready for production use So I want to say somewhere between 5 and 6. Like 5 was looking at it. And Doug Lee and I were going back and forth on the right way to do this, and you could implement them, but they were non-trivial things to get right.
We implemented it in 1.1, it was synchronized. So it's kind of a minimally, a idempotently safe, minimally synchronized, multi-reader, multi-writer.
Yeah, a bunch of guys did striping. And concurrent hash map was the first guy that I knew that went big that was the readers never actually had to take a lock, as opposed to striping where the readers still take a lock, but you hope it's not.
Well, the real hard part was always around, so map is basically 2 different data structures in one. It's a key value store where everything is a key-based
lookup. Yep.
So it's an RAII model in terms of there's a demarcation point where you're going down into scope and then you come back out of scope to answer the question, right? So get key goes down, gets value, comes back, release.
Yeah.
Put key value comes through the scope, comes back out. But then you also have a key set iterator.
Yeah.
I return the iterator. So I've returned state.
Yeah.
And now I've got 10 threads that call iterator. They have 10 different iterators, and they're iterating while I have 100 other threads doing removes and puts.
Yep.
Right. And so it's like, how do I? So those removes and puts are still RAII compliant, and the iterator is sitting out here, but I popped out to return the iterator, but the RAII is actually outside of the scope of the iterator itself. Right. So it's a long-term scope that lasts until the iterator is garbage collected, in theory.
If you want the iterator to hold on to keys that it saw at the creation time.
For example, so snapshot iterator versus stable iterator versus fail fast is always easy.
Well, the general rule for those where you may see keys that were there at the time of creation. You will always see keys that were there at time of creation through the end of the iteration.
Right.
If you remove a key during iteration, you may or may not see it. If you add a key during iteration, you may or may not see it.
Right.
And that's the efficient way that those end up, as opposed to fail fast. Yeah.
And what ends up happening, of course, is that, way downstream, some application developer gets an iterator and they iterate over it slowly, doing something with a database. And in the meantime, a whole bunch of other people come along and whack away at the data structure, and it works great in development. And then they put it into production.
Yeah, and it
and there's a concurrent modification exception, and it dies, right? So it's like, okay.
Yeah.
Scala has some implementation. I'm trying to remember, TrieMap or something that it's a concurrent and gives you consistent iterators. I would try to find.
You can grab all the keys up front. Certainly, concurrent hash
does a versioning, I think, is what Tito is talking about.
Yeah, it's a tree-based concurrent.
Yeah, I'm saying that the concurrent hash map, both mine and Doug's, do not throw concurrent modification exception. But an application may not see the expected key set.
Right.
So Tito, are you talking about concurrent skipless map?
I
That's pretty much tree-like.
A Stack Overflow, the fifth linked and
oh, there it is. It didn't turn it into a link. Usually Google Docs just link you.
I turned it, yeah, but it didn't recognize it.
Yeah, I got the link. Yes. Okay. Oh, I see. And then it captures them all. I would be curious to see what the cost overheads are for having, for all kinds of things. Yep. Yeah, I will imagine without running it that it has way more overheads than non-blocking hash map, but it does give a consistent iterator, which is interesting.
Yeah, Yeah.
Yeah. And I do not.
Yeah, TrieMaps or Patricia. They call Patricia maps.
Yeah.
They're pretty awesome in Java because you can actually reduce them to, we used them to reduce the object count in maps. So with a hash map, for example, each entry is at least 5 objects.
Wait, what? 5?
Yep. Yep.
An entry.
Yeah.
Yeah, a key and a value, which you could claim or two, and the object that the map entry.
I can't remember the details, so
I'm up to 3, but I didn't get 5.
It may have been for specific types we're looking. So string, for example, was always 2 objects.
A string will add 2 for that, but then
so this is years ago, so I'm pulling from distant memory.
It's a lot of overhead.
Right.
That's for sure. And like non-blocking hash map does not have hardly any objects per thing you put in.
So the tray, though, you can encode a lot of stuff almost structurally, and if it's too big to encode, you just split it into 2 tiers anyway. So
yeah.
So it goes from 1 object to 2, but
yeah.
Anyway, they're fun.
Yeah.
So that's how we did the terabytes of data with almost no objects on the heap. Was using trays. So we got it down at one point, so it was just over 1 object per entry. So very logarithmically close to 1 object per entry in a large distributed hash map.
Okay. And there's an H2O model. So not counting non-blocking hash map model is an average of 4 words per key value pair.
Mm-hmm.
The key and the value themselves of their own cost. You point at the key, point at the value, and 50% load factor. And no other objects. So you get the one big array effect out of that.
And we had some fun use cases as well, because we deduped the trie as well. So you'd have in serialized keys, you'd have long strings of duplicated values. So we could actually end up with the data set actually using less memory once it was in memory than the size of the data set.
That was the H2O game. Boy, you compress, that was a whole lot dedupe, and shit ran faster and took less space.
Well, you guys took it to a much
well, we didn't do arbitrary. We did column compressed. So it wasn't like taking JSON wads and then deduping JSON wads or something.
Right.
But under column data,
the challenge we had is that our data models were kind of pre-done by some customer. So they had built their own classes, and we had to somehow make them
go. Yeah, I mean the serializer in H2O would go do all kind of games there on the Java objects he was serializing and deserializing. He would play those during over the wire, but he wasn't trying to make a heap representation that had been deduped and we modified. But he definitely.
If you're ever bored and feel like making a talk about the H2O serializer as compared to Parquet, which pulls a lot of the similar tricks, I would be curious about that.
Well, hand in hand with the serializer, the key value store, I guess it's the fastest one I ever was able to measure. It was both the densest, wireline format and also fastest key value store and exact.
You were optimizing for read speed. You didn't care as much about how long it took to create it because your ETL was expensive, right?
I had bulk writes. I optimized for bulk reads, and heavily cached reads. The one time you paid an interesting cost if you were multiple unrelated nodes were mutating the same key. If everyone mutated different keys, fast as you could push the data over the wire with no return overhead costs, so no latency, bandwidth, not latency. Bulk read, bandwidth, not latency. Bulk write, bandwidth, not latency. You're reading the same key over and over again. You got it local in your memory every time, and you only did local updates. You're reading and writing the same key, but the key is home somewhere else. Again, You went at memory bandwidth speeds for yourself, and other people would only see updates rarely if they were looking. But as soon as you had reading and writing here, and well, no, if you had multiple writers, then you in different nodes, then you had the latency hit. But if you had multiple readers and one writer, the multiple readers took a latency to get new updates, but there's no latency for the writer to write. He could just write back to back to back to back as fast as his memory would allow.
But if this is a columnar compressed format and I change one of the keys in the middle, don't I have to re-encode the rest of the block?
Yeah, that's all done on your own node. It has no memory bandwidth to anyone else. I mean, no network IO latency to anyone else. If you updated a big data key value, you were always the home node for that guy. That's the guy who did those updates. Because he's the home node, he doesn't have to push it over the network. So he had an old copy and he has a new copy, and people got the old or the new according to when they racially read versus your update. And then when you got the new one done, you had an atomic install and you threw the old one away, and the garbage collector picked it up after a little while. But no one else had any latency on it. So that makes sense there?
Yeah, because it's the Java memory model. So
the Java memory model for the cluster. The Java memory model for the node was also true, obviously, by the JVM, but that had nothing to do with nothing, except it meant that you could have a guy on your same node racily read while you're trying to write, and then it was a racy read, and he got some of the older or some of the new, according to wherever you're at. The usual.
Did that
updates,
ever get you into trouble with a consistency problem in racing reads followed by writes?
No, because people didn't do incremental minor writes. You did bulk writes, and then you just synchronized at the bulk scale. Like, I computed a new thing that I'd never seen before from some function of horrible old things. Okay, no one's seen the new thing until it's written, and then they read it fresh as I wrote it. So that's one model. It was a common case. Another model was, and you would do update in place by saying, I don't have a reader, or I'm going to stall the reader because I don't believe there's one right now, in which case I'm just going to update. And when I'm done with a full bulk update, I will then declare all the writes done. I will allow a reader in. Then there was
the H2O answer to OLTP is don't do OLTP. This is an analytics platform.
This is an analytic. I don't know what you mean by OLTP here in this context.
Online transaction processing.
We supported you doing atomic updates on keys, and those were consistent across the platform, actually at the speeds I was just mentioned, at the really good speeds. So the one time you could see something funny is if you had a local node on the same shared memory reading from a compressed state where the other guy was writing, and the compression strategy was remaining the same. So the writer was doing an incremental byte-wide update of a value, which happened frequently, but it was not the case. You had a reader on the same guy reading while the writer was writing. But you could arrange to get in trouble if you stepped outside of the usual coding model. But if you lived with a sort of normal bulk coding model, you wouldn't have any issues. If you also wanted, instead, I have an interesting transaction and I want to read either the pre or the post of the transaction, then we had an atomic transaction update. And if you had multiple readers and one transaction writer, the readers got either before or after. That was atomic, and they had a latency, not bandwidth, not latency. So if the writer was doing continuous transactional updates of a single key, readers would only ever get the before or after of one of his many transactions he's doing in a row. That was commonly done for progress bars. Some guy at the top of level of an algorithm computes a new progress bar and he updates it in a shared place, and all the readers, which come from everywhere all over, are looking for progress. Go check it.
Yeah, I don't need strongly consistent progress. That's fine.
Yeah, well, you got it. And so you're only inconsistent, literally only inconsistent, if you had a shared memory reader and writer on the same node where the reader was reading while the writer was writing, but that wasn't part of the normal analytics platform coding. So that one, you know, people did model management control, and usually it was just an H2O engineer internally doing something racy that he knew what his trouble is. If you were a user of the platform, you couldn't write such code unless you sat down and wrote raw Java code, and it tended to go screw that way.
Sounds fair to me.
Yeah, I mean, that was, yeah. And the big win out of that was the systems engineers, H2O engineers, all understood the Java memory model, and you just coded to the Java memory model on a cluster scale, and it worked. You didn't have to think about it. That was easy to use. All right, fine. I walked away from that platform. I use it time to time still, do analytics. Fine.
And now you're moving to the ocean.
Yeah. I wish them the best of luck. This is in my life, you know, I've had sort of two big betrayals, and H2O was one of them, and divorce was the other. But out of the wreckage of that, I became the person I am now, and in particular, no. And you know, I've got to enough to retire early, so can't complain how it turned out in the end. Although I think there's a lot that could have, should have, would have been done with H2O, yet that's not been done. A lot of potential there still.
We'll do an AA version of H2O.
There you go. Yep.
Yeah, that's the other question is if you had AA back then, would you have built H2O in AA?
Oh yeah.
Instead of Java?
Yes.
Okay. And why is it?
Oh, because it's my toy. Because I got this thing, and you know, in Java land, I could get performance by understanding how the JIT worked and understanding how hardware performance model works in general, and you know, not shooting myself in the foot. What I would think, it seems obvious to me, but it's not obvious to other people. I don't understand why it's not obvious. Fine, that's my lack of human understanding. But I had to work around it. Java, you know, didn't hand me certain levels of performance. It did hand me some. It handed me a lot of things you could do that were commonly done that would be bad for performance, like allocating a capital D double for every double on the platform. That is shoot you in the foot quick. So I could shoot myself in the foot, but if I didn't, I could get performance out. One of my goals out of AA is performance-wise, you have to ask to let yourself be shot in the foot a little harder. You by default won't shoot yourself in the foot. And if you find it's too annoying, you can say, loosen up the rules a little bit, and then I'll let you do more things that are, you know, less performant and don't care, but they're syntactically easy. That was one of those goals. The other one is get rid of a lot of the ceremony that came with Java. Public, static, final. You've seen me put up, you know, boilerplate for the primitive nodes. The line describing the semantics for an add or multiply, it's 90% ceremony. Public, static, final, prim node, you know, add node, extends, prim node, open, curly, static, final, apply, you know, int, apply, takes two args, open, close, return. Okay, now it says A plus B. It's just like.
That was the one thing that never really bothered me about Java. It's like it is verbose, but
I
mean, get a bigger monitor was always my answer.
Yeah, I got a big one.
What? No.
The story I told earlier about hacking at Sun and performance of the people and what happened. One of the things that came out of that was the bug rate was correlated to the number of lines of non-comment code. It was not correlated to how fast you wrote. It was not correlated to how dense you wrote. It was correlated to the number of lines. So denser lines meant more functionality per bug. And that's why I write my code dense. I wasn't sure. I hated it when people did fluffy code. I see Cameron's code and I just like cringe. But I've done the math. And at least on the hotspot code base over those 10 engineers over 3-4 years, the more lines of code we wrote, the worse it was.
Your style may be more efficient, but the denser the code, it's harder to, you have to stare it for days in order to.
You have to read
there's
the same volume of information.
When I skim through your code, I get the impression what it's trying to do, but there are nitty-gritty details that they matter, and it's when the code is denser, it's just harder to understand. The Java verbosity and the types.
I think it depends on the person though, because I've met a few people that they read dense code and they cannot read nicely aerated code.
It's like Java.
It's like aerated, meaning like lots of bubbles that push the letters apart.
It's like Java.
Vertical space and blank lines. And
Java is so verbose that the type just hurt your eyes. That's a common expression because you have to be literal about everything, and well, we hope AA will fix this, but not go overboard with the dense code.
That's my style, and I won't tell you to go write it that way. My experience is I prefer the dense code to get more done in a line of code because it has fewer bugs in my experience. Fine. Is it now, can you go overboard? Oh, I'm sure you can do. Everything can be done too much of. And what's the right style? I will write the too dense style first and decide it was too dense and back it off. But I'm certain that there'll be other people who would rather write a fluffier style, and it's going to work for them. And I'm not going to say do it your way, do it my way.
Certainly, everyone has a style of doing things.
Yep. So, I call mine Clifford normal form. And I've been using it for a very long time.
APL and
okay, if you,
two gets.
If you write EBNF grammar for the Cliff normal form, I will write the sugar compiler, which will turn it into a more.
Let me show you some specific instances here.
Cliff does really well considering he doesn't have an enter key, a space, a tab, or curly braces.
So here is an if statement. You'll notice that there's a blank after the paren and not before it, like that.
Yep.
Okay, and why is that? And that's because that paren is syntactically, part of the, I go back here, I lost my if, fine. All my ifs are that way. Is syntactically part of the if. You can't not have it. It's not allowed to not have it. So as far as I'm concerned, it's the same token.
Yep.
So I separate my condition from the if keyword by putting the space here as opposed to here, which I see a lot of Java people. There's another one that does this, and that's just making things fat for making things fat. I'm just not going to do that one.
Okay.
And then, I have this whatever pile of eye chart with no curlies, right? And this is where, Cameron might say, you should have curlies everywhere. And I'm like, I don't like this style. It just added some vertical space without giving me, not saying Cameron or anyone else, not giving me any more understanding. So I get rid of the extra curlies. And then this in here is just a series of function calls in a row that are semantically stupid, so they're all jammed together. Fields.get. Well, the .get is like an array lookup, is a little bit more intelligence. It's a read barrier. It does a quickie check. If I fail the hash function, I get the default. That's the key test I'm making. S.get, same as the fields.get. It's just the other guy. It's a this and a that. I don't call them this and that in this particular piece of code, but I could. It's asking the question, if I find one here and I find one there, and I do an is-a test and they fail, get out. So that's the, it's.
So we actually require the curlies now in Ecstasy, unlike Java.
Okay.
And that's just a reflection of some of the issues that we've hit over the years in code where someone accidentally put a semicolon after their for or after their while. And the C compiler didn't pick up the fact that they indented the next line.
So in the case of Emacs, I get the auto indent thing. So whenever I screw up indentation, the editor immediately re-indents for me as I edit on a line, and then and then immediately in my head I'm like, this is the wrong indentation, and I have a unbalanced thing going on.
Oh yeah.
But that's the editor popping up and saying, you have failed indentation, so I'm going to re-indent for you. And then you're like, wait, no, error.
So the compiler didn't catch it, but the editor did.
Yeah.
It's,
And of course, here I have curlies.
It's a reasonable argument if you could dictate the the coding standards.
Well, I understand.
In the tool chain.
Right, I understand. But in AA, I have limited set of uses for curlies, and I want to keep them that way. Right now, plain curly is always a function, no exceptions. The curly with the @ sign in front is always a struct, and there's no scope. There's only functions or not the functions. And so I'm still sorting out if I'm going to do separately scoped in any other way that you want to scope per se. Now you can put arbitrary variable declarations in the middle of expressions, and you can use round braces to just group things, 3 + 4 × 5, and
but
just
the real
grouping.
question, Cliff, is the real question is, if you were a real programmer, wouldn't you be using VI?
No, because VI is stupid. Let me come up with some other bad, personal words for why not to use VI. I'm a VMAX guy. I grew up Emacs, so stop it now.
I never use it, neither VI nor Emacs nor.
I don't know what
nothing.
you're missing.
You have no idea how many arguments you're missing out on.
Yeah, so I've heard. So I've heard.
Yeah. So, all right, but the curlies for me in AA, it's no curlies because it's the function boundary.
When Scala 3 introduced the space indented syntax, I immediately thought that's a stupid idea. But more and more I look at it, it's just a preference of style. There are certain things that look a lot nicer when you space indent them, and sometimes you just want a curlies in a block and indent it however you choose. I'm kind of making my mind that both styles aren't bad to use.
So here's the uncolored. I wonder if I can just say some color in it. Not very much. Here's a larger piece of AA. Do I need curlies? Well, I don't know. Hash table is a variable. It's defined to be a function that makes a new struct, which is a hash struct. So if I just call hash table, it's like saying new hash table. Okay. Here's the search as a internal function from a list or key. So the linked list lookup. Curlies are being used for functions. Here, again here, again here. Do I need curlies?
Aren't the arrow indicative of a function?
Sorry, say again?
Aren't the arrow indicative of a function?
Yeah, the function is curly, some number of parameters and an arrow. And the arrow is optional if you have no parameters. If you want to thunk something, you can just put curlies around it and it becomes a thunk immediately, a no arg function.
That's for sure. It's shorter, but doesn't it lead to confusion?
This guy right here is a no arg function because the curly doesn't have an arrow.
No arg function, which returns your struct.
Which returns your struct, yeah. So the use case for this is to say, some table is equal to hash table, and it's a function, so I'm going to call it. I made it, and in Java you would have said new hash table. So that's.
So if I put curlies with no arguments and no arrows, and I knew something in that function, it goes away at the end of the scope.
That's a function which returns me a 5. So say again now, I'm talking while you're talking, so I'm being bad. So it's my bad, so say again.
If I declare a variable inside that block, it goes away at the close brace?
Yeah, it's lexically scoped. Yeah. So there, I've declared a variable y in that scope. It goes away when the scope exits. And I have a function called 5, returns me a 5. If I call 5 like this, I get a 5. And, you know, there was a y in the middle here. It's just dead code. We'll see, you know, another indentation on that. The editor understands that I'm trying to write C code and he's trying to indent it, and it's not C code, so he's confused.
Yeah, that seems like clear enough to me.
Okay. One of my goals was to say I could comment out big chunks of code by just putting curlies around it as a thunk and make it become a function to be called instead of actually execute. That was just as a convenience for, I need to make this code disappear for a minute.
I used to see people do that in TCL code, that they would just put a bunch of stuff in an if0 as a block comment and be like, okay.
Yeah, right. Yeah, you can write a block comment that way. Here, this following information is true and type correct, but I'm not going to call it because I don't want to execute it. I just want you to understand that it's type correct. I have an assertion here that I'm going to write as a piece of code without meaning otherwise, without throwing an exception or being a runtime test. It's just, I'm describing some complicated situation in code. And then, you know, this is sample AA code that I haven't tried compiling in a while. I was missing key bits to make it run, which I'm now getting close to having done. So it should be able to go at some point. Like here's the length of an array. Pound. That is Java tab.length. And it's actually pound is it's just an operator. It takes an array argument and it's called on the array. Like arrays have a class like ints that supports the operator pound as a prefix operator and returns you the length of the array.
In Java, it's a one-off opcode.
Yeah. Yes, exactly.
But hash table, as we spoke in the earlier conversation, hash table isn't the class. It's a lambda calculus, pure thing, something.
Right. This hash table up here is a variable name.
Yeah.
It is assigned a function which returns a struct which has no other classes. So it is a prototype one-off struct.
Okay.
I could make a name for that struct if I wanted to call it, you know, a name. I could give it a name. And now it has some sort of class name, but as this is an anonymous struct.
Can you extend its functionality a la trait implementation mechanics? Extend the functionality of hash table outside of definition hash table.
I need to have I can't add to the existing struct that got built here. But if I have a name for that struct as a type name, then I can go add to it by using that type name in another type definition in another constructor and the like. So if I say animal is a type name, which is in a variable, it's assigned with colon, it's a type name, and now it has, you know, legs is equal to 4, or maybe I really want legs as int, and you know, sound exists, and I don't know what it is. I have an animal.
So let's be. Okay, yeah, that is it. It's not a record. It's a type because it doesn't have a definition. It doesn't have a values in it.
Yeah, and now I can say cat is an animal with 4 and whatever. Yeah, I guess.
This amounts to a new instance.
That amounts to a new on the cat. Yeah. The indentations.
And the parentheses are just doing grouping.
These parentheses.
Can I call by saying animal space and then some argument?
The parentheses are just doing grouping. So animal is a type here. Two things happen here. Animal becomes a type in the type space. It becomes a normal variable in the variable namespace. the normal variable is finally assigned a constant constructor, a function. So animal as a type declaration gives me two definitions. In the type space, it's animal, and in the normal namespace, it's a normal variable that happens to be the constructor.
If you want a custom constructor, let's leave the functional way apply would be in Scala example, a custom apply function, which is a custom constructor, which with amounts to a custom.
Okay, I haven't written the custom constructor syntax here, but the custom constructor syntax will start with the base animal and then have another another set of arguments. So if I have animal 2 or animal n, which, you know, standard animal, how about this? Standard animal wants to say, I just take a sound and I return you an animal with 4 in the sound. And now I've got an overloaded function for the variable named animal, one that takes 2 arguments and one that takes 1. And I'll have to do resolution, decide which one you're going, but I do it based on the number of arguments. It's easy. Done.
It's it's overloaded.
It's an overloaded function. Happens just call a constructor. Okay.
Yeah.
Then to extend animal, I use another type here. So I have a colon, and then I would say animal colon curlies, and now more fields. Right.
Okay. This amounts to a composition, which is animal is a it's in base type, if you will.
Yeah.
And it has an extra field, has tail.
It has an extra field. Yes. Yeah. And you know, we could argue the tail is mutable, so I can change it to false if you're a bobtail of some kind or another and I don't have a tail. And then, you know, that one is.
So how can you extend? Let's say you wish to extend the cat with a new function.
Okay. Oh, extend cat. No. So cat has. I have put a function. I put it here. So you know.
You cannot post declare the cat hasn't some new functionality. For example, the trait in Rust can define a new method outside of the definition.
Cat is defined right there as animal plus the following fields. If I want to make another version of a cat that has more fields yet again, I can make an anonymous struct.
Yeah, I could imagine a piece of code that's got 6 lines in it, and the first 5 are all anonymous structs as you're building up some object, and you only name the last one.
Yeah.
I feel like I've seen systems where you get weird extra types that only exist during the construction of some more.
Yeah, I end up with builder models, I would call those, where you have a builder and then you have a final thing. And in the land of my types, where all types are interned, but I have to build cyclic types, I have to do builders. And so it's obnoxious in the
Mostly,
Java layer.
I want that because I want my thing to be immutable when it's done.
Right, I want it immutable and done, but cyclic. So I have to mutate somewhere in there. I cannot whole cloth make a cycle. So I end up with this builder thing. Fine. Yeah, so what else we got here? You can add, so you can add more fields on a guy. This, by the way, this thing here, this is producing a constructor for a new type. It didn't actually call it. Because it's a constructor, I could call it immediately. And this would make me a new struct out of a cat object that had an extra field called myfunc. And make an object.
The cat, what's the type of the cat? The cat
would be an anonymous type that is a regular cat plus also has myfunc, but it's anonymous.
So we trace on the width trait with some base class with some extra functionality.
I guess. I don't know what width means in this
With
context.
in Scala, width means you can
Base.
define a base class, and you can mix in the like in the Cameron case, a new anonymous with
Okay.
execution.
So this is not a mix-in. Well, it's a one-off mix-in, but I can imagine producing a mix-in syntax, and semantically, the mix-in has obvious implementation in my type system.
To me, it looks like a mixing in this form.
I've done an anonymous mix-in, a one-shot anonymous mix-in. Suppose I wanted a mix-in that I'm going to use in a bunch of places. So I want to give it a name. Right now, I don't have a syntax that lets me do a mix-in of that form, but you can imagine something here.
But you do. You just drop the at. If I define,
no, I put a name here. It's my other mix-in. This is my mix-in called mix-in.
Hey guys, I'm gonna run. Have a good weekend.
Okay, see you.
Cheers.
And we're somewhere in the world, I said mix-in is equal to a type that has something else. And here I want to say, take all of cat and all of mix-in, and I will do something with collisions that's same.
In a world, this would be easy because it's structural.
I have to make sure the mix-in doesn't override cat, or if it does, there's well understood rules.
Okay, so if on that next line I say file equals reader : writer : seeker, and those are all defined things.
You want to go write this in the Google Docs?
Not particularly, since I'm on my phone right now.
Oh, okay. So say again what you're trying to do.
Okay, so file as a type.
Yeah. Oh, file as a type. Okay.
And I want to say that is the mix-in of reader, writer, and seeker.
So with the intent, these are like interfaces, if I'm understanding.
Okay.
But if I assume that reader, writer, and seeker are all defined structs that, you know, has a function named read, a function named write, and a function named seek that have whatever signatures they have, will it get mad at me for that?
You know, right now, this is not syntax that I accept. Now, can I imagine doing this in the type system? Here's where you have to come up with a thing. You have to decide what to do with, I don't know what other permissions here.
Since we have no notion abstract here, we don't know what to overwrite. They will overwrite each other, but we have.
I have to deal with file descriptor twice, once on the reader, once on the writer. And then I could complain that this is an error because reader and writer both have fields called FD, and I don't know how to mix them.
So we can do something sensible here. The writer is first, the reader is first, the writer is second, the seeker is third, and in this from left to right, they overwrite each other fields. So the last guy wins.
Yeah, there's a thing that says override, but it doesn't give you the behavior you're typically looking for, which is to say, I have one field that's common to them both. So this gets into C++ multiple inheritance, right? Do you have two FD fields or one FD field? So I changed the description here to make the one FD field obvious. Now I have two offset fields. And are they independent fields? Maybe my reader and my writer are different offsets, and maybe they are separate fields.
This, I would argue, this is the compositional way, not the class inheritance way. You factor out the FD in its own class, if you will, and you mix it in. You make the bigger class. It contains the abstracted class.
Okay, and where I'm coming around to is, I have to come up with a meaning for what it means to have the same field name appear in both, and how you access them both.
Why do we need them? Or if we inherit them, so to speak, in quotes, we refer to the same things.
Okay, so in this example, I'm assuming the same file descriptor, two different offsets. So somewhere in reader here, auto indent's going to kill me here. I have a read call which takes some number of arguments, whatever, and does something. And under the hood, it read, modify, writes offset. it does something horrific to its offset.
Hmm.
The writer has the same game.
In order to keep it consistent, we have to have two copies of offset because
We have two offsets because the reader and the writer are writing and reading at different offsets. But this file supports simultaneous reads and writes. They're just different offsets. Oh, as a for instance. Okay, now in whatever code comes out of this guy, if I call the dot write call, I'm okay, and call the dot read call, I'm okay. I would probably claim I can't look at your offset field because it's inconsistent when I say file.offset. So file.offset is not allowed because I don't know which one. So instead, I made it private.
So Go does something similar to that, where if you inherit from two structs and one of them has the field and the other doesn't, you can just use its name. But if they both have the field, you would have to say new struct dot name of the old struct type dot the value, and it won't let you call it if there's a conflict.
Okay, so I'm sorry if I have I said file.
You would have to say file dot reader dot offset or file dot writer dot offset. You couldn't simply say file dot offset
like this
because there was a conflict. It would be like conflicting name, ambiguous. Sorry, no.
It forces you to disambiguate it what you are calling the offset with. Is it the reader or is it the writer?
Yeah, right now my dot call, my dot syntactically only does field lookups. So I don't have this syntactic form of dot reader as a disambiguation.
For the type, it would be. It's not.
I'm not claiming I can't put the syntax in, but in the land of simpler syntax, this makes dot have two different behaviors according to its use.
Dot must refer
I agree. It doesn't feel very
it has to have either different syntax to specifically disambiguate the type, because the dot, it's overloading. Is it the value? Is it the type? Is it? I don't know. It's.
So in the land of casting for overloading, there's this, which I'm not using that as my syntax for overloading, which right now it's thinking me like this. And that could, having declared it a reader, I like the Java thing where you give it a name.
With the desire for AA to have a clear cost model is to make you resolve that when you're defining the type.
Right. So the other piece of that is to say, well, fuck you, this is an error. And then you come in here and you said offset R and offset W. Right. In fact, I don't have to hide it anymore. I can say read offset, write offset. So, there's a way around to allow you to do the mix-ins and just demand no conflicts, rename your fucking fields. But I got my fields from some other third parties who don't agree on each other. Then you can't mix them together. Put an indirection in instead. Right? If I have two conflicting structs that I want to mix, but they can't, then you just use an indirection.
And if I put an example of, if I have a struct that has two other structs in it.
Hey, see you, Cameron.
And I do top level struct dot sub level struct dot field. That's still going to collapse to a single access, even though there's two dots.
So say again now, if you do struct embedded?
If I just put reader and writer into file.
Yeah.
Then it just becomes its own struct and the names aren't ambiguous because I have to say either file.reader.whatever. Right.
Actually,
this is the same composition over inheritance.
Yeah. And here in the land of AA, if the constructor is declaring these things as not reference objects, but declaring them as value objects, and there's a way to say that you're a value object, not a constructor, not a reference object, then these are actually inline structs. And it's semantically, it's still field lookup to say file dot r dot offset. So that's a field lookup semantically. In the cost model, I'll come to you and say fixed offset, one field load, not two.
Yeah, I kind of like this as a, yeah, if you're getting name conflicts, then don't do that. Like, use the construction.
Right.
Here, the ceremony is so little. I wouldn't say it's a ceremony at all. You can just define it as a composition instead.
Yeah.
Yeah, I'm actually pretty happy with this. I mean, I would write a heck of an error message for the first one. That's like,
yeah, right.
You can't actually do this, but here's a way that you can solve the problem. I rewrote it for you. Have a nice day.
And if you're annoyed by dot, error dot, something, you can go either the Jonathan Blow way, use something that would import the statement, and so you wouldn't use the dot error dot offset.
See, now there's an interesting question. Is it acceptable to have macros in error statements that say you wrote this badly, but here is a snippet of code that is based on the fact that I parsed your other code and rewrote it for you in the error message?
Okay, wait. If I have error code that is dead, I'm just going to parse and go. I don't care. There's no macros. There's no macros in A.
Right. So my argument is you've got some kind of error because you tried to combine two things and it says, sorry, you're overloading the same name.
Right.
Can I look at that and say, if you want to rewrite this in the compositional model, and I'm going to make the field names the class names in a standard way, I could give you the actual code that would be the valid replacement in the error message.
Maybe I've some of those things I've seen people try, and some of them work out well. And sometimes the guy just makes a guess and it's horrific, and he gives you some higgledy-piggledy piled mess of nothing that means nothing. So you kind of, it's quality of error messages, and sometimes it works well and sometimes it does not. Usually you're making a mistake like this, you don't understand the basics of the language in the first place. So the error message is confusing already. The error is confusing, the error message is confusing. The cut and paste code you got out of it was unrelated to any sort of correctness because the compiler was confused, you're confused. You cut and paste it in, the situation did not improve.
And here is another question. Can you leave? We are in the middle. Can you leave an error the type reader in writer, which would be?
I'm sorry. What has to do with handling?
We can omit the types, the error column reader, and we can omit.
If you say file.r.offset as code, the last line I got there, I will know that I need file has a struct that has a .r field, which has a struct, which has a .offset field.
Yeah.
Now I won't make an OS call to go do the OS file read out of no type inference there.
I believe no. I'm asking in the file definition that a reader we can omit the type. Yes, in the definition of the file.
So the file needs some definition. Suppose I did file is this, and I wanted to, now what are you trying to get me to omit? Where am I omitting something?
Omit error, the column reader, you just leave it an error. The error and W without error types. Can we do that?
So if you just say R comma W close brace and it's just any's.
No, what type inference does, it says if you don't have a type, I'm going to infer it. Here, you've given me a type called file. I'll take whatever you write.
Okay.
So there's no inference. I don't come to you and say, it's a struct filled in. Mr. Type infer, fill this in. Instead, I won't have a file at all. This won't be there at all.
Yeah.
And you'll just do file-like things with it.
Okay.
So you can imagine somewhere else in the world, I've got a code that's, he's supposed to take a file or sprintf, whatever. He's supposed to take a file type thing, right? So let me write this in good AA style. And, here I demand you pass me a file thing. It has to have all the file, has to have a type code file which meets the criteria. That whatever in the dot dot dot, somewhere in the guts of dot dot dot, I said f dot right dot whatever right blah blah blah. Okay, if I get rid of this file, type inference comes along and says f has a w field. The w field has a right field. The right field is a function that takes some arguments.
Yeah. Which is not what we want.
Well, it's not what you're asking for. You're asking for, I said file as a type in the world. And I just left it like that, and somehow I inferred what it means. And down here I said file. Okay, here I can tell you that the file I have in here, I don't find the name, so I'll blow up on you for the name. Like if you don't have this name, I'll say, no, you got no file name, I'm gonna blow up on you. And you're like, I want to infer this type, call it file, and let me use it later. So that's not, I mean, there's something I could do, but I don't know what syntax or how we deal here. It's like here, whatever thing f is, it's gonna have a type. Whatever the type is, I'll put 2 colons here. Whatever the type is, call it file. Now, later on in life, use file in a meaningful way.
I mean, the intuitive, at least to me, syntax for that would be file : file.
Oh, okay.
It'd be like file is just recursively defined as its stuff.
It's whatever I infer.
So on the line before that, if you type capital F file : capital F file.
Oh, like this. Yes.
And it's like, yeah, it's a type, but like,
but what is
I'm not telling you anything about it. Infer things.
Right. And here I said, oh, you have to use that here. I don't
would say
know.
the behavior should be the same as if you simply hadn't included file in all of the places where you had to do the inference anyway.
I mean, I could do like this, you know, I mean, get rid of, I mean, I don't know, I need the thing there.
Oh yeah, that is less ceremony.
But if it's an argument or let's say a function, we can omit it and ask Hindley-Milner to infer its type.
You know what I heard Aaron say is, I want to, well, maybe both, yeah, what you said is true too, Theodore. So I want to have a complicated type. I want it to be inferred because it's too complicated for me to sort it out. I want to
It's a pain for me to maintain this because I'm still making changes to my code and I don't even really know what my type is going to be.
But I want it the same everywhere that I use it. I've definitely used it here, here, and here. I want it to be that thing. Okay, maybe.
So the main place where I want to use this is I'm about to make changes to this type. I essentially want to comment out the type definition and replace it with just figure out something for me because I'm messing with this type right now. And then when I'm done, I want to go back to having a defined type so I get good errors. But while I'm playing the game, I kind of want to can you just like pretend that file is a please infer me?
Right. I think I can do that. I think Hindley-Milner, I'll tell you what file is. And then I'll also demand it be used the same everywhere that it's being used.
If it's
it means I don't have to comment out every use of file everywhere in the program because I'm fiddling.
Right.
As soon as you write f : something where some like in the nominal world, it has to have something named that way.
Yes. Now f is nominal. It has to have file. It also has to have all the fields that it uses, which have to be part of file.
Yeah.
So f cannot use things that I can infer and discover about that aren't part of file.
If you want something that resembles a file, you can make it an anonymous struct that it wants these fields and these names. That would be. The nominal naming will cut the search time because it's right there. It's either you have it or you don't. But what with the example when f is an argument to a function and you totally can omit its type, and Hindley-Milner will come up with its type.
Yeah, well, that's what sprintf's doing here, right? So somewhere in the world, I said sys.sprintf whatever sys.out. Comma, oops, right? I pass sys.out as a file to my sprintf code.
Yeah. Okay.
More obvious.
Mm-hmm.
No, I think that's a cool language feature.
Yeah, I like where it goes. I'm going to move all this stuff into the doc and claim it's like time to be done.
Yeah. Well,
Yes, we're definitely over.
And no, oh god, it added extra spaces everywhere, and it didn't color code. Fine. Oh, it didn't. It's just very bulky font. That's fine. Okay, never mind. I'll quit trying to edit the text. Yeah.
All right. Thank you very much. This was a good week.
Excellent. Excellent. Yeah, it's always fun to go talk about AA syntax down there and sort it out where I'm at. But so as you can see from behind me, Aaron, I'm mid-move. So again, not so much done this week. Sorted out the last typing theory issues. When you came in, some people were here when I started talking about moving.
Are you on with just one person?
No, I'm down to 5, kind of myself 4. All right.
okay.
I'm gonna bail. We're gonna go do lunch and then get back to moving.
Yeah. Okay.
Okay, my wife's gonna sneak behind me because she's behind me. Lemon tree, getting our lemons.
Yeah.
All right, next week, maybe.
Okay.
I'll let people know via Twitter if we're on or off next week. My theory is I'm on because we're still in this house packing, and the computer will be the last to go. The week following may not, or may not. That'll be setup week. All right.
Okay. Bye. Till next
See you
week.
again. Bye bye.
Clearly, Tudor is going to have to run that week.
What?